Welcome back, everyone. This is Michael Gibbs, and I'm the founder and CEO of Go Cloud Architects and Go Cloud Careers, and I'm super excited to be here with you for today's AWS Certified Solution Architect Associate 2022. This is a free full AWS course. It will help you with the AWS SAACO2 or the AWS SAACO3. Really makes no difference because of what we're teaching you, how we're teaching you, and why we're teaching you. This is a completely free AWS Bootcamp to help you with AWS certification, specifically the AWS Certified Solution Architect Associate Bootcamp. So this is another AWS Certified Solutions Architect Associate 2022 Bootcamp to help you pass the associate exam. We are honored and delighted to be here with you today to help you build your cloud computing future. And I want to help all of you on your path to getting cloud hired. So we'll probably talk about some AWS career tips. We'll talk about some cloud computing trainings. We'll be giving you things that are appropriate to help you with your first cloud architect job or your first solution architect, because I want everybody to get cloud hired, or else why bother doing what we're doing? Before we begin today, I want to go through some housekeeping. This course is meant to go along with our ebook and our labs for you to sign up for. We have a beautiful 450-page book full of labs that will help you with the AWS Certified Solution Architect Associate and Professional exam. Please build that book. It will explain to you what is the tech, how do we use them, and really help you in your cloud computing career. And it's completely free, so please download it. Now, we run our course a little differently than other people for good reason. We want you getting hired, not just certified. Anybody can get you certified, but getting you hired is somebody different. So when it comes to getting hired, or it comes to mastering the cloud architect interview or the solution architect interview, even the cloud engineer interview, what people want to know is, do you understand the tech? What is the tech? How does it work and why you should use it? What features, benefits does it bring to the business? That's all we care about in hiring. When it comes to hiring, we don't ask you to configure, because then again, architects don't configure. We don't ask you to code for architect positions because architects don't code. We're not going to be looking for Git projects on your resume because architects don't do that. In fact, it'll make you look less like an architect. Architects design, present, and sell. Now, you can't design anything that you don't understand. You can't really present anything that you don't understand, or it's going to sound like a certification course. PowerPoint slides with blah, 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 because you can't present what you don't know either. And you can't sell what you don't know either. So I want to make you all better. I want you to be the best cloud architects in the world, the best solution architects. So I still want you to get hands-on. So sign up for special access for our labs. And that frees us up to teach you what you need to know for the job instead of worrying about screen sharing. Our screen sharing is pre-recorded. Go after it. Get it. It's free. Enjoy it. Take our class where we'll actually educate you on the technology. And then go read the book. Take a very simple practice test, and this exam is literally nothing. It'll be simpler for you. But it's a lot easier when you know what the technology is. So we're excited about that. So please sign up. Next Thursday, we have our How to Get Your First Cloud Job webinar. Please join us. Today we had a big fun time. We had people from all over the world. Hundreds of people showed up. There was about 70 people on at any one time. And we talked about what is the cloud architect role. We talked about leveraging your life experience to show the hiring manager of experience when you don't. We talked about exactly what you need to learn exactly to get that first cloud architect job. And we answered questions specific to people's careers, because you can do that on Zoom. It's on Zoom. It's lots of fun. After that, we did all kinds of stuff. We showed you how to skip those HR people to get your resume directly in the hands of the hiring manager. We told you what your resume needs to have. It was a party time, and we loved it. So there's that. So please sign up for the completely free How to Get Your First Cloud Job webinar next Thursday. Now, while we're at it, my average student gets bombarded with interview requests. In fact, on Tuesday night, and if you haven't seen it, I encourage you to see it. We had one of my really bright, fine young men. He was 25 years old, has an associate degree. He got his first grade cloud security architect job. And I asked him, did you apply for any jobs? And he laughed at me, Mike. And he said, why would I apply for jobs? He said, I don't want to go through HR. He said, you taught me how to build the perfect LinkedIn profile and resume profile. My biggest challenge was turning down offers. He had 3 job offers with 0 experience. Because of this, because the average Go Cloud career student gets bombarded by people trying to hire them, we're offering for basically practically free, only $99, a LinkedIn resume, a LinkedIn workshop, and a resume workshop where you can be like our students and have the world come to you instead of furiously applying for jobs. Now, once it comes to that, it's up to your knowledge of how to be an architect to get hired, but we can help you get those interviews. And if you can't get hired, then we can train you to be hired because our students get hired every day. Now, when we looked at the inflation numbers that were out there, they were pretty scary. So I asked my team to choose the lowest cost that we could offer our products for as long as we can sustain it, which is 30% off. And we have a 30% coupon code on all of our products. Use the coupon code POTENTIAL. Potential. When we had 25-year-old Delroy Bad on, and I said, could you now, after 1 year of my training, afford a brand new single-family home and 2 Mercedes cars? And he says, yes, that's what we try to do, and I want to do it for you. So that's what we're offering, a 30% off potential to help you get to your career goals. Now, later today, and more frequently, we're going to be posting so much more on LinkedIn. In fact, we will be posting around 3 p.m., ideally before this thing ends, a post about how you can get hired in a down economy. We were recently interviewed by a magazine. I'm going to ask if my team can post that at some point today while I'm giving this presentation. And I want you to read it. So please follow us on LinkedIn because I don't want you to miss anything. I want you to be armed. I'm working with Eva Doikian now with 13 things on interview questions to help you get cloud hired. I've got things that I write for magazines every day. I make a thought leadership piece every day about career optimization, so please follow both me and Go Cloud Careers on LinkedIn. Now that we've gone through the housekeeping, let's do things while YouTube is still notifying everybody, come join us, because there'll be a lot more people soon. Please do the following. Give me a hashtag that says AWS Certified Solution Architect Associate 2022. Please put that in the chat box. And while we're at it, please give me another place where you're located. I'm over here in Port St. Lucie, Florida. I know we've got Kostas by his name. He's in Greece. Kalispera, Kostas. We've got Leo, who's over there in Sao Paulo, Brazil. Leonardo, I know, is Brazilian, living in Germany. I'm loving this because we're so international. So Rohan's over there in Houston. Fantastic, Rohan.
Mike, can you repeat that hashtag again?
Hashtag AWS Certified Solutions Architect Associate 22. Nigeria, New Mexico. Wow, how awesome. Oh my God. Whoever's got this cat, clouds to the moon. This is a beautiful, beautiful cat. Tech D47, whiskers in the clouds. Yeah, I love whiskers. What a beautiful cat that was. Tech G47, we're a fan. I'm so happy to have you, and you're coming in from Twitch, which we just started using this week, and we're super excited to be there. Douglas G, AWS Certified Solutions Architect. Leonardo, AWS Certified Solutions Architect. Tarun, AWS Certified Solutions Architect. Ashley, AWS Certified Solutions Architect Associate. Toby Leo, AWS Certified Solutions Architect Associate. Mr. Gee, I love that name, AWS Certified Solutions Architect Associate. AJ, oorah, and thank you for your service. AWS Certified Solutions Architect Associate. Terry Glass, Kentucky, pretty cool. Douglas G's over there in Maryland. Delhi, India. Latasha's in St. Lucie. AWS Certified Solution Architect Associate. I'm loving it, Carl. AWS Certified Solution Architect Associate. Joseph over in there in Nigeria. Fantastic. Carl's over there in Denver. Terrence is in Ottawa. MMA Let's Talk. I love that. Omar's in Washington, D.C. Martin is in, I know he's in Europe. AWS Certified Solution Architect Associate. And Virginia P., AWS Certified Solution Architect Associate. Dr. Joseph, AWS Certified Solutions Architect Associate. Collins, Texas, fantastic, Collins Z. Marjan's over there in Amsterdam. I knew it was in Europe. Asheville, North Carolina. Mr. Businessman over there in Georgia, fantastic. And Virginia P., San Antonio, and Leonard Lash. Leonard's a great guy and a fantastic architect, AWS Certified Solution Architect Associate. Tracy Mayo, she's wonderful. She's AWS Certified Solution Architect Associate. And Lee Golf over there in Atlanta, AWS Certified Solutions Architect Associate. Woohoo, we got people who are starting to show up, so let's get into the content. All the fun begins. So I don't know whose cat that was, but boy, that was one beautiful cat. Cameroonian in Dallas, fantastic. So let's begin by some introductory to networking reviews. I'm going to tell you right now, we're going to glance over networking. The cloud is nothing more than a network in a data center that's been virtualized, so you need to know networking. Two of the critical networking things that you need to know are subnetting and supernetting, IP addressing, and BGP. They're not all of them, but they're two really critical things. So last week, we ran a free subnetting workshop, and we also ran a free BGP workshop. And we spent hours, and we had fun. So please, if you have not seen our subnetting workshop or our BGP workshop, please go see them. Somebody from my team, please provide the links. You can watch them after this class. But today, what we're going to do is introduce some introductory networking concepts. And we're going to start with the OSI model. And why did we come up with this OSI model? We came up with an OSI model for a reason. A reason. It enables networking professionals to use a common lexicon or a common language. So over there, we got Kostas, who's sitting there in Greece. If I say Kostas, post Isimera, which is how are you today, he understands me. But if I say that to Leo on my team, who speaks fluent Spanish and Portuguese, Leo, post Isimera, Dikanes Leo, he's going to look at me like I have two heads. Now, the reality is the cloud providers have done it for us. Elastic Compute Cloud, Google Compute Engine Instance. It's the same silly virtual machine, just call it a virtual machine. But see, we networking professionals, we medical professionals know that if we don't want errors, we have to use a common language. So when we networking people and we architects talk to each other, we don't use terms like S3. We use terms like object storage because we're speaking the same language. Otherwise, mistakes happen. Now, when networking people talk to each other, we talk in terms of generics. In fact, we created a model so that we could troubleshoot networks together. And whether you had a Cisco router, a Juniper router, Billy Bob's router, or somebody else's router, we're still speaking the same language. We don't use terms like elastic, except in the terms like economics when we're talking about price elasticity. We may use real terms that customers understand. So that's where we're getting the open systems interconnect model. The OSI model is the foundation for networking, and it's how networking person 1 talks to networking person 2. So it's a 7-layer model, and each layer is a certain layer of information. Now, networking people like me, pure networking people, only work on the first 4 layers of the model. But it's a 7-layer model, and we're going to explain to you what each layer does so you can have an intelligent conversation to the network engineer, network architect, or any professional in the technology space. It's a brilliant model. It's a very simple model to learn, but I want you to understand it. It's divided into 7 layers, and we're going to make it very simple so you understand. Layer 1 of this model is the physical layer. What does that mean? If you buy a connection from point A to point B and it's a wire, it's physical. Your Ethernet cable is physical. Physical connection. If you don't have the wire or a radio frequency thing or a fiber optic cable where you're sending photons of light, you've got nothing. So layer 1 is the wire. Now, what do we send on this wire, whether it be a fiber optic wire or a glass wire, a copper wire or a fiber optic wire, which is made out of glass? What are we really sending? Bits. Just bits, basic elemental bits. So layer 1 is your wire. Now, many of you have an Ethernet card in your computer, and you plug in that wire. Now, where you plug in that wire, it gets plugged into a card. That card is layer 2, or the data link layer. So layer 1, wire. Layer 2, data link. Now, at this point, whether it be an ISDN from millions of years ago, like one of the first clouds I worked on, or the frame relay cloud that I worked on in 1996, or the ATM cloud that I worked on in 1998, or the VPLS cloud, which I worked on around 2001, it was all layer 2. And what do we send at layer 2? We send frames. So back in the frame-relay days, we had Delsies, which were the layer 2 device. And in ISDN terms, we had Q921 and Q931 setup messages. But here's what we're dealing with here. The MAC address on your computer. So layer 1 wires and bits. Layer 2 MAC address, hard-coded address, or framed. Then we move a layer up to the network address. Logical address. You put it on there. Your IP address. For people that are old like me that worked on AppleTalk addresses and IPX addresses from the old Novell networking days, we used other kinds of addresses. So packets at layer 3. So layer 1 is your wire. Layer 2 is your Ethernet card. Layer 3 is the IP address. It's a logical address you can put on it. Now, next is the transport layer. How do I send the information? Am I sending real-time streaming information, which is sent via unreliable transport intentionally? Am I sending some critical information that I need to make sure it's guaranteed to get there? I use TCP. So layer 4 is this transport protocol where we determine flow control and how do we send our data. So look at it this way. Layer 1 wire, we send bits. Layer 2 MAC address, we send frames. Layer 3 logical address, we send packets. Layer 4 is a TCP, UDP, or ICMP, and it's called segments, and we do flow control here. Now, layers 5 through 7 aren't really things for network architects like me, but we're going to talk about them anyway because we're cloud architects here. Layer 5 is the session layer protocol. And here what we're dealing with is like a socket. And this is really about controlling the connections on both sides, and we're sending data at this layer. That's why once it's data, we're way above what network architects do. So layer 1 wire, layer 2 Ethernet card, layer 3 IP address, layer 4 TCP, UDP, ICMP, layer 5 sockets. Now this next layer, we networking people do a little bit of it over here. This is the presentation layer. And this is where the information is presented to the application, and it also translates that data to the other layers below it. Now at the layer 6, or the presentation layer, encryption happens here. So TLS type encryption, SSL kind of encryption, that kind of exists here. So layer 1 wire, layer 2 frame, layer 1 MAC address, layer 3 IP address, layer 4 TCP, UDP, ICMP, layer 5 socket, layer 6 presentations and data. Now layer 7 is the application user interface. What do we mean by this? Well, when you go to your browser, Chrome, that's an application. When you open your Outlook email client, even though I may be one of the last people in the world to be using it, that's an application. So that's your application layer. So let's think about it one more time. One more time. Layer 1 wire, physical layer. Layer 2 data link, hardware like your MAC address. Layer 3 network layer, logical address like your IP address. Layer 4 transport, TCP, UDP, ICMP. Layer 5 session, we deal with sockets and control the connection. Layer 6 presentation, typically your encryption layer here. Layer 7 is the applications, the things that you and I click on and use every day in our ordinary lives. So now you know the 7 layers of the OSI model. Now we're going to get very gently on IP addressing, but please see that subnetting workshop. So every device needs an IP address. Do you have a house or an apartment? Do you have an address in your apartment? Why? You get mail, right? How would the mail know to go to Cindy's house, which is my house, versus Noni's house, which is Abigail's house? How would the mail people get there? You've got an address and it must be unique. Now, I may be living on 123 Main Street, which I'm not. Abigail may be living on 123 Main Street, and Chris may be living on 123 Main Street, which none of us are. But let's assume we were. Well, it would be different. How could the people deliver our mail? Well, I'd have a different postal code or zip code than Abigail than Chris, so it's still unique. So mail delivery is similar to packets. Remember, layer 3, we send packets. Packets. Every device needs a unique address. Now, we're dealing with 2 versions of IP addressing, IPv4, which is 99% of what we do. It's been around for a long time. IPv6 is the newest addresses, which have also been around for a good 20 years, and they're used for things like cell phones. They're still not widely adopted, but they will be in the future. Now, inside of your systems, in the cloud, in your internal networks, like anything else, you must be using private IP address space. So what does that mean? Well, you can do what I do. I get all my specifications from the Internet Engineering Task Force. All manufacturers do as well. So if you look in RFC 1918, you're going to see some subnets or some networks that have been reserved for you. And they are as following: 10.0.0.0/8, which of course you would subnet down, the 172.16.0.0 all the way to the 172.31/16 and the 192.168.0.0/16. So actually, when we deal with 172.16.0.0 all the way to 172.31.255.255, what we're really dealing with is the 172.16.0.0/12, which of course we would subnet down. Now, you're going to hear the term CIDR on your exams. What does that mean? Well, about 100 years ago, and I've been in networking for 25 years ago, and we were using classless interdomain routing or CIDR before that. We used to have these classful addresses, and we gave up on it because we would use up all of our addresses basically in a single week, a single day in today's world. But this was the 1.0.0/8 all the way to the 126.255.255.255/8. They were our Class A addresses. And then somebody said, well, do Class B addresses. There'll be a /16. And we chose 128.0.0.0 all the way to 191.255.255.255.255.16. And we came up with these Class C addresses, which were 192.0.0.0 all the way to 223.255.255.255/24. And then we came up with Class D addresses, which were used for IP multicast, which are 224.0.0.0 all the way to 239.255.255.255. Here was the problem with that. Here's your Class A. On that Class A, you've got 16.7 million addresses. Now you got a server that's got two Ethernet cards in it, right? They each need to be on a different subnet. So if you did that classless internet, the old-fashioned classful routing, we'd have to burn 37 million addresses on two interfaces on a system. Clearly that wouldn't work. So everything gets subnetted down. And that means classless addressing. So what is classless interdomain routing? It means we just subnet and supernet our systems and we don't use the classful boundaries. So any guys that had a networking background and you used Cisco 20 years ago and you'd get into EIGRP and you would have to set up something that says no auto dash summary, this is what we're talking about. For those of you that don't know that, don't worry about it. So in today's world, we use classless addressing. Now with subnetting, we break down one thing into a bunch of little things. For supernetting, we take little things and we bring them back. So we're going to be adjusting our subnetting sizes as we need. I'll give you a couple quick examples here to show you what it is. And then after that, if you're not familiar, please watch those videos that we talked about. So here's an example. Let's say you have a Class C address, at least standard Class C. 192.168.1.0/24. Now I can stick that on one interface on my computer. But let's say I've got a router or a server with 4 Ethernet cards. Well, I can't use that subnet on multiple ones, but I can chop it up into little mini subnets. For example, I can create the 192.168.1.0/28. And then I could do a 192.168.1.16/28. And then I could do a 192.168.1.32/28. And then I could do a 192.168.1.48/28. And then I could do a 192.168.1.64/28. And I could do this until I run out of addresses. So that's why we're using subnetting. Now on the cloud, it's a little bit different. And I'm going to give you 2 guides right now. WAN links, point to point, basically a wire. My left hand and my right hand are on the same side of the wire. How many people can be on a wire? 2, source and destination. So what kind of a subnet link do we use for a wide area network? A /30, because it enables exactly 2 hosts. Can't even sneak another one in there. Great. Now, what do we put on a LAN segment? I'm going to tell you right now, use a /24. AWS will tell you the smallest subnet you can use is a /28. You'd be insane to use that /28 on a LAN subnet where your servers are. And here's the reason why. You think you need 11 servers. And then you need 20. And then you need 30. And then you need 100. I promise you, whatever you think you need, it's going to be more than that. Now, why did I say /24? Because that's about the biggest subnet you can create in all practical purposes, because all systems send broadcast traffic to each other. Too much broadcast traffic will knock your systems down and destroy. In certain cases, you can get as big as a /23, which is about 500 plus hosts in a subnet. Beyond that, it's all noise, noise, noise. ARP, ARP, ARP. Bonjour messages, server message block messages. I mean, it goes on, and goes on. So keep that in the back of your mind. That's exactly the reason why we have to subnet our systems down, and we can never go bigger than a /23. So don't use a /28 unless you're going to use it for some kind of weird link. Use /24s on LAN, /30s on most wide area connections, and you'll be good to go. So what is route summarization or supernetting? It's the exact opposite of subnetting. And again, watch that free subnetting webinar. It'll be very clear to you. But here's what I'm going to do right now. I'm going to give you a little bit of an overview as to why. When I deal with networking and I connect to 3 internet service providers, I get 800,000 plus routes from each internet service provider. So I'm dealing with 2.4 million routes. When you connect to AWS, they say, you can give us 100 routes. 100 routes, that's nothing. I mean, literally nothing. And all the cloud providers have very limited networking things. And that's why every time they say, brand new, look at this new networking thing. What does it get us back to? Something that was that either came out in 1985 or 1998. Just like AWS said the other day, brand new press release, we can now put IPsec over direct connection. And I looked at this and I sent it to like 30 CCIEs and I said, didn't we do this back in 1998? And they said, yes. And I'm like, how can they make big claims? And they're like, well, look how bad cloud networking is, considering what the rest of the world's done 20 years ago. So it's big and exciting that we get close to the old days. So there's that. But because we can only give AWS 100 routes, and this is not because of their weaknesses at all. Imagine they have 1 million customers, and they each get 100 routes from 1 million customers, 2 million customers. Well, now you understand the routing problem. So they only let you give them 100 routes. So if you have thousands of subnets, and most organizations do, what we have to do is take these little mini subnets and combine them together to a single route. So I can tell AWS, here's one route for 4. Now, look what I did here. I took 192.168.0.0, 192.168.1.0, .2.0, and 3.0, and I summarize it into a single route, 192.168.0.0.22. AWS only needs to know that. So AWS will send their traffic from the VPC to my router, and my router has the intelligence to know where to send it. So what is route summarization really like? Imagine this. I want to go visit Kostas in Greece. And for me, I want to get to him. Now, here's the thing. Let's say I don't exactly know all the pathways to get to Greece. But I do know this. I know that if I get to London Heathrow, some plane will get me to Greece. Maybe it's Olympic Airlines. Maybe it's something from British Airways. Maybe it's Alitalia. Maybe it's Delta. Maybe it's Turkish Airlines. There's going to be somebody that's going to get me to Greece. So all I really know, like all AWS needs to know, is how to reach your data center or how to reach London Heathrow. When I get to London Heathrow, I can get there and I can say, get me on a flight to Greece. And they say, Mike, we've got this beautiful Olympic Airlines flight. I don't know if they still exist. They've got really good food on the plane. And I get on that plane. I get in my seat. Maybe I drink a Mythos beer or an Alpha beer on the way. And then I get to the Athens airport. Now, or the Thessaloniki airport. I don't know where Kostas is. But let's say Kostas is in somewhere near Athens, like Piras, very close to Athens, or Elefsina, or a city near there. I need to go to Athens. I get to the Athens airport. Now, when I get to the Athens airport, I can get in a taxi cab and say, get me to Piras, and the taxi is going to know how to do it. So route summarization is the following. Giving people just enough information to get to you. Now, we network architects do it for lots of reasons, routing, scalability, reduction in router memories, but on the cloud, You can only give them 100 routes, which is basically zero. It's a big fat zero. So you got to be good at your route summarization. We'll talk very briefly about IPv6 addresses. Look, it's a newer form of addresses. IP addresses are a 32-bit address, 32-bit binary address, so zeros and ones. You want to know how many addresses we have max? 2 to the 32nd power, minus 2. You'll see it's a lot, but it's not that many. Now, IPv6 is a 128-bit hexadecimal address. Hexadecimal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E, F. Wow, that's 16 of them, right? From 0 to 16. So 16 to the 128th power. That's what you're getting in terms of IPv6 addresses. I don't think we'll be running out of them anytime soon. That's bigger math than even I can do on my scientific calculator, because I don't think my scientific calculator will go that far out. So now you know what we're doing. Chris, how long have we gone so far?
About 20 minutes.
Okay, so before we get into any more content, and for deep subnetting questions, we're going to point you to the video. Are there any questions that need to be addressed? Is it overkill to multi-cloud your email service? Oh, if your email is important to you, you have no choice. You have to multi-cloud it. So generally, at least 2 clouds. Anything that matters should be in 2 clouds. Now, can a business survive without email? Probably. And if a business can survive without email for extended periods of time, you might knock it out. But if email is critical to the business, it better be in more than 1 cloud. It must be. Nothing good can be in a single cloud, because all clouds will fail. All internet service providers will fail. It's not if, it's just a matter of when. Was any cloud provider able to get to 99.99% available last year? No. And that's not even high availability. So nobody can get to 99.99% last year, let alone 5.9. So no, you always need, if it matters, you need multi-clouds. But if email is not critical to your business, then you can get away with it. Good question, Dylan Williams. James Yang, what's a MAC address? Great question. So every device at layer 2 must have a physical address. With frame relay, we had DELCs. With Ethernet, we have a MAC address. So what the MAC address is, a hardware burned in address on your Ethernet card. It's a hardware address. And there's 2 parts of this address. The first half of the address is something called the OUI, which identifies the MAC, the manufacturer of it. The second part of the MAC address is the individual address. So what you'll see is like something in the beginning, which will say this is made by Broadcom or Cisco or Intel or whomever. And the second half of it is the unique identifier user. So it is the hardware address that's associated with layer 2 Ethernet. But James, and it's a great question, every layer 2 technology has a physical hardware address. You already have a boot camp for the associate cert. How are these lives different? Okay, I'm going to make this really clear. The associate certification, for the most part, is the name of a service and how to configure it. I'm going way above and beyond that. Way above and beyond that. Our live training is so, or are you asking about our associate cert? Oh, so, okay, so we have a boot camp for the associate cert, which is this. And we also had a pre-recorded one. They're basically the same. The pre-recorded one is one I pre-recorded about 1.5 years ago, and these have been updated. Now, if you're asking how our live training are different than that, in our live training, we teach all the skills to become a cloud architect, which goes into the executive presence, the leadership skills, the communication skills, the emotional intelligence skills, the business acumen skills, the CXO relevancy, what needs to be on your resume, how to tune your resume, how to negotiate a higher salary, and all the networking and data center things that you need to design across multi-clouds. So everything you need to do to get hired. So they're very, very different. But I wasn't completely sure the questions you're asking. If you're asking me about the pre-recorded live thing that we put out about 1.5 years ago, you can't ask questions. It wasn't live. And this has much more content in it because this gives us 5 days to do it. And we didn't waste any time on the configuration videos. You take them home and do them on your own. And we also give you live chances to answer questions. Is all cloud provider only support 100 routes? All the cloud providers support such basic minimal networking. Cloud provider networking is the equivalent of 1999 networking. But you got to check the provider's information every time because it's getting better. Last year, AWS announced a revolutionary new thing. Everybody was so excited. All the AWS sales reps and all the certified people, what do you call it? They shared it 1 million times. And it was that AWS allowed East-West Routing, which was routing between subnets. Now, we did that back in 1985 at Cisco. You can see how far cloud networking is from the network architects like me that have been working on it for decades. But it gets better every day. So with every architecture, with every design, and even for the engineers that know how to build it, every time you need to go to the manufacturer's documentation. Reading 5 minutes of documentation will save you 5 hours plus of troubleshooting if you're an engineer. And reading 5 minutes of documentation for the architect will keep you from getting fired. Because if we design something wrong, you know, our replacements will thank us for our beautiful jobs. Good question, though. You missed part 2. Did we cover subnet and supernet in part 2? If not, can I explain the benefits and usage of a subnet and supernet? For deep, I spent 4 hours on this, so please watching this. Here's the thing. If I gave you you had a server with 4 interfaces, and I gave you a 1.0.0.0/8 for one, a 2.0.0/8 for two, the second interface, a 3.0.0/8 for the third interface, and a 4.0.0/8 for the fourth interface, I would be wasting 64 million addresses, and we don't have a lot of addresses. If instead I gave you 192.168.0.0/30 for one interface subnet, and the next one we use 192.168.0.4/30, and the next one was 192.168.0.8/30, and the next subnet was 192.168.0.12/30, I'd be burning 16 addresses versus 64 million addresses. We have a very limited number of IP addresses, and we must do that. Now, supernetting, my network has 30,000 routes in it, which is pretty normal. AWS only allows you to give them 100. You got a supernet, or they won't be able to reach any of your systems. Now, it's not just that. You've got 30,000 subnets in your system, and some of them go up and down. All your routers have to recalculate it. You know what happens when they recalculate? The CPUs hit 100%, and the network crashes, and then you got nothing. So this is critical things. Here's the good news. We spent 4 hours teaching this just last week. My team will put a link to that workshop. Please watch it. Any others, Chris? Does a VPC have a virtual MAC address? A VPC is a virtual private data center. Data centers don't have MAC addresses. Now, every server you have has a MAC address. Every virtual router you have has a MAC address. Every internet gateway you use has a MAC address. So every device has a MAC address. Switches have MAC addresses too. Routers have MAC addresses too. But your VPC is a virtual data center. Data centers don't have MAC addresses. Any more, Chris? When we say IP addresses, are we talking about IPv4, IPv6? Remember what I said in the beginning of the day? Most of what we're dealing with is IPv4 addresses. They're primarily what's used. And they're using private addresses, and we're subnetting it down. Now, we're starting to use IPv6 addresses, and where we really are using our IPv6 for the most part is mobile phones. But over time, we'll start using them more. How much more training is required for the professional versus the associate? Look, Virus, these are basic introductory level certifications. You know, to prove how minimal they are, if you know what you're doing, I spent 2 days preparing for the Google Professional Cloud Architect exam. Now, I knew cloud, but I knew nothing of the Google Cloud, and I could do it in 2 days. The training we're giving you right now is more like the professional and the associate combined, but the way they ask questions in the exam is the dumbest I've ever seen on any exam in my entire life. It's pretty much a sales exam of how much AWS stuff would you be willing to sell if you were a sales rep. Has no architecture in it whatsoever. So if you know what you're doing, Forrest, if you're like me and you've worked in it a long time, when you deal with these AWS exams, you have to forget what you know and what you do in real life and try to do it as if you were an AWS sales rep and you were trying to sell as much stuff as you could. What answers would you pick? And there's usually a right answer on that exam. But it's a very basic, simple introductory level exam. Nothing, seriously nothing, when you're properly trained. If you're improperly trained, it's going to be challenging like you can imagine. Okay, so let's do this. Give me a hashtag, AWS Certified Solution Architect 2022, or Associate 20. I'll say it again, AWS Certified Solution Architect Associate 2022. Please put that in the chat box. I know you are awake, alert, and oriented. I'm going to answer Dylan Williams' question. Does the Go Cloud Engineer course cover DevOps? Engineering, we cover some DevOps, so we have to. Architects don't do DevOps, so no. But absolutely. If you want to be an architect and you put DevOps on your resume, we will have to remove that because it'll cut your salary in half and make you unhireable. If you want to be a cloud engineer and you know some DevOps, that is great, great, great. And I had an application architect teaching some DevOps principles to my cloud engineering students just the other day. But it's all based upon the career you want. Architect, design, present, and sell. Engineer, configure, code all day long. That's your decision. Margin, a Certified Solution Architect Associate. Mr. Gee, AWS Certified Solution Architect. The person with one of the cutest cats I've ever seen that looks like Cindy, AWS Certified Solution Architect Associate. Leo, AWS Certified Solution Architect Associate. Leonardo, AWS Certified Solution Architect. Tech V47, AWS Certified. Marla, I'm so happy to see you here, AWS Certified Solution Architect Associate. Abigail Marks, who is one of the cutest cat named Noni I've ever seen, one of the cutest ones, AWS Certified Solution Architect Associate. Lars, AWS Certified Solution Architect Associate. Moses, AWS Certified Solution Architect Associate. Tantrum, AWS Certified Solution Architect Associate. Mufaz over there in Nigeria, I'm so happy to see you, AWS Certified Solution Architect Associate. And Brian McCool, AWS Certified Solution Architect Associate. Chris gets back to the comment. If you haven't subscribed, please subscribe and hit the bell to be informed of new videos and new things and all the new free things. I can tell right now, I'm going to go check and see if you're subscribing. And if you're not, please do so. We work really hard to do these things. We spend about as much money as buying a car every single time we do these free boot camps. So please like, comment, subscribe, share, and tell a friend. So now let's talk about the VPC. Now, the VPC is not what people call it. They like to say it's your virtual private network. It's not. Here's what a virtual private network is. You go to the internet and you create a tunnel through the public network, where you basically have a wire and you send your information across multiple VLANs. That is a virtual private network. Guess what? We're not having on one side and the other side. Routers. And a virtual private network, you don't put your servers, your storage, or any of your cool stuff. What has that? It's a data center. So your VPC is your virtual private data center. So what are and that's where your virtual machines are going to be housed, not only your other critical stuff. So what is the networking components of the VPC? It's going to be routing. Understand routing, which means routers. We're going to be dealing with internet gateways, which are internet-facing routers. We're going to be dealing with egress-only internet gateways. We'll talk about what they are. We're going to be talking about NAT instances and NAT gateways and what they are. We'll talk about elastic IP addresses and Vpc endpoints and Vpc peering, network access control lists, and security groups. It's going to be party time, party time, party time. So the first thing that you need to understand is in order to get your traffic from point A to point B, you need a router and WAN or LAN or whatever. So what does this mean? It means your VPC will have a virtual router. Why is it virtual? Well, I can't ask Alonzo from my team to go to the AWS data center and rack a Cisco or Juniper router in there. He's not allowed in. So because of this, we use virtual routers. Hence the reason we can't deal with as many IP addresses or subnets, because they're virtual, not physical. Now, what happens is the routers are going to build themselves a route to the network, and they're going to create something that looks like a routing table. And I'll show you what a basic, cloud routing table looks like over here. If I can figure out which one is the right window over here, bear with me a second. So this is what your routing table is going to look like. And routers are always going to prefer the most specific route. So here we've got 172.16.1.0/24. It says local. That means it's directly attached. Then you can see we've got a 192.168.0.0/16 go out interface 123.456. Now you'll notice we also have a 192.168.1.0/24. Now notice that is actually contained in the supernet or router aggregated route up top, but this is a more specific route. And routers always take the most specific route. And that's why 192.168.1.0 goes to this interface PCX 654321. Now you'll notice the 0.0.0.0/0. What's that? That's what's called the default route. If you don't know where to go, go there. What do we use for default routes generally? That's generally headed to the internet. So keep that in the back of your mind. So what routers do is, let's pretend I've got multiple interfaces, and I'm the router. Packet comes in here, and I say, go out that way. Packet comes in here, and I say, go out this way. Packet goes here, and I say, go that direction. Packet comes into me, and so it's kind of like a game of hot potato. Packet gets to the router looks in its routing table and says, go out that interface, or go out that interface, or go down that interface. Routers are just servers with a bunch of ports on them. Now, when we're dealing with routing, we're going to be dealing with the following. And if you can hear some screaming in the background, what's going on is the cat's outside and there's some thunderstorms and my family's trying to find the cat because the cat doesn't like water. So the way routing tables are normally built is organizations have what's called an interior gateway protocol. And this interior gateway protocol is optimized for speed and self-healing. But what it's not optimized is for route filtering and scalability. So we will all have our own internal routing, and AWS has their own internal routing as well. And then when we connect our entity to an external entity, we have to use eBGP, which is exterior version of BGP. Now, if we wanted to carry the BGP routes across our system, we would run something called iBGP, or internal or interior BGP, over our internal network. So inside of our network, we use an interior gateway protocol. And from networks to networks, you will have an exterior gateway protocol. Want to be a cloud architect, you better understand this. This is critical network knowledge. But that we're showing you the way the routing works. Now, when you connect to AWS, you have to give them information. How does AWS come back and reach your data center? And you need to know, tell your data center users, how do we reach AWS? So you've got to do some routing. Now, if you're using a VPN, you could, though I wouldn't recommend it, do a static route. What's a static route? I want to get to Chris's house. Take I-95 north for 30 miles. Make a left on this highway for 50 miles. Make a right on this highway for 50 miles. And make a left on this highway for 75 miles. And bam, I'm at Chris's house. Bam, like that. So that's great, right? Now, what happens when the road's blocked in front of me? I'm sitting in there waiting for the road to be unblocked. That's static routing. Next, we're going to do dynamic routing. We're going to be using BGP. Now I'm on the way to Chris's house. I get on I-95. And all of a sudden, there's some police officers blocking the highway. So I go to my GPS, and it says, recalculating. Mike, make a left here. Make a right there. Roadblock. Make a left. Make a right. Make a left and right. An hour later, I've got my cat, Cindy, and Chris's cat, Sunny. We're hanging out, having a good time. The cats are playing together, and life is good. So what kind of routing are you really going to use if you want your systems to heal each other? Dynamic routing with BGP. Now, at this point, I'm going to tell you, if you don't know BGP very well, I recommend you read the book, Internet Routing Architectures from Bassam Halabi. I recommend you look at all of the Internet Engineering Task Force RFCs for this. And I'm going to tell you, I want you to watch my BGP video. Chris, can you pop the link in the chat box, or somebody from my team? I spent 4 hours on BGP, and we made it simple, simple, simple. So we use BGP due to the scalability and the tunability. Now, you need to know how BGP works for the job. But test question, BGP operates on TCP port 179. Test question, BGP operates on TCP port 179, which means if you've got a firewall between your entities, you need to make sure that TCP port 179 is open. When we connect to 3 internet service providers for optimized internet routing, we must use BGP. And when we connect to AWS over a direct connection, we must use BGP. So BGP is critical. And here's the sad reality. BGP is not covered in the AWS Advanced Networking. So it's an exam that's teaching you networking, but it's not teaching you the stuff you need to do for the job. But it is a good intro to junior level of networking. When it comes to BGP, it's got lots of tuning options, which we talk about obviously in our BGP training. But here's the thing. AWS has some BGP tuning options. It supports the BGP community and now export. And what that means, which is good to know, is if Abigail gives me her routes, and then I send Abigail's routes to Chow, and Chow gives me her routes, and I send Chow's routes to Abigail, Chow and Abigail can talk to each other through me. And if I want them to, great. But if I take in Abigail's routes and give them to Chow, and then Chow gives them to somebody else, and vice versa occurs, half of the internet can go through me as transit, and I could be paying for half of the world's internet. So we don't want that. So AWS does support the community no export. What that means is Abigail gives me her information, and my routers won't send it to anybody else automatically. There you go. AWS BGP implementation is light, but it does support many of the BGP attributes, such as weight, local preference, AS path, and also the more specific routes. But we can only send them. So this means you're going to have a good IP addressing plan and add to your address routing. Now let's talk about an internet gateway. You're going to need this for any time you want your systems to be reachable on the internet. So what is an internet gateway? It's a router that connects to the internet. That's it. A router that connects to the internet is called an internet gateway. Here's the good news. It's a logical router. What does that mean? It means it won't crash. Normally, you need 2 physical routers. But in this case, it's a logical router which can't crash. Now, if the cloud goes down, it'll crash, which is why you always need more than one cloud. But as a rule, your internet gateways are solid. They say no performance constraints or bandwidth limitations. There's always performance constraints and bandwidth limitations. Check each time, your miles may vary. So how do you use an internet gateway? You attach this virtual router to the internet, to your VPC, and you create a route that says use this. Now, what's the route going to look like? Well, you can't take in a full BGP routing table. So what's the route going to look like? It's going to be default route 0.0.0.0, 0.0.0.0, or 0.0.0.0/0. What does that mean? If you don't know where to go here. Okay. Now, anytime you've got an internet gateway, you've got a router on the internet. Now, this means you need a public IP address. AWS made up some real slick names for the public IP addresses, which we'll get to soon, but you need a public IP address. Now, you've got an internet gateway and a public IP address. Your systems are now reachable from the internet, which means they can be hacked, which means you're going to need to lock them down securely. Now let's look at it visually. Here's what you got going on here. In this particular environment, you've got some systems, some servers. Now, normally you'll have these servers behind a load balancer, where the load balancer will have a public IP address on it, and your servers will have a private one. But here's the case. You need this external IP address on this router. And you would also, if these servers are not behind a load balancer, this server would need a public address, this one and this one, if they all serve different purposes to be reachable from the internet. So that's an internet gateway. It allows your traffic out and your traffic in. Okay, so next is something called an egress-only internet gateway. What is ingress and egress with regards to network traffic? Well, here's the thing. Let's say you wanted to go to your favorite fast food restaurant. I don't know. I haven't eaten at McDonald's in 25 years, but I do remember I used to like a Big Mac. So if I want to enter the McDonald's parking lot, that's considered ingress. When I leave the parking lot with my car, that's called egress. Going in is ingress, going out is egress. So now we've got something called an egress-only internet gateway. What do you think that means? It only allows your traffic outbound and not in. So the egress-only internet gateway is an IPv6 gateway that connects your IPv6 system to the internet. Now, here's the thing. Your systems internally will be able to go out to the internet and their traffic will come back. Happy, happy, happy. But your systems will not be reachable from the internet because that's ingress. You can go out, go through, and your traffic will come back. So why do we use something? If you don't need to provide externally facing services, you want some kind of an egress-only gateway. Why? You got systems behind the firewalls that need to update their operating systems. They need to go to the internet for that, but you don't want them reachable, so that's why we use them. It's an egress-only internet gateway, but that's for only IPv6. Now, you probably won't see them on the exam anymore, but I'm going to show you what they are just in case. It's something called the Nat Instance. AWS doesn't recommend it these days, but some people still have them. What is a Nat Instance? It's a machine, a virtual machine that translates a private address to a public address. And then you connect that to an internet gateway, an internet-facing router. And basically, it's available as a pre-made virtual machine. And it allows your systems to have NAT, where basically it doesn't just use NAT, it uses something called PAT, which is Port Overload Translation, which is different than that. And basically, it'll take your IP addresses internally and make them look like a single IP address to the outside world. So NAT instances, along with an internet gateway, allow the following. You to go out and connect to the internet and your traffic back, but it doesn't allow any ingress traffic. So what does this look like? It looks like the following. Basically, what you've got over here is you got your private subnet, which is where your systems are, behind the firewalls, etc. And then you've got your NAT instance. And in your NAT instance, it's a virtual machine that translates one address to another address. And they really shouldn't call it a NAT instance. They should call it a PAT instance, which is port address translation, because that's more of what's going on here, called NAT overload or port address translation. And then it connects to the internet gateway, which is the path to the internet. So now you've got a little bit of information on how this old technology works. Now, the next thing that AWS said is, well, that's awfully complicated. We need a virtual machine and an internet gateway. No big deal, but whatever. So they created something new. They created the NAT gateway, which is the IPv4 equivalent of the IPv6 egress-only internet gateway. So if you've got systems behind your firewall that you don't want reachable from the internet, but you want your users to be able to go out to the internet to update their operating systems, patch, download stuff, you need a NAT gateway. Now, a NAT gateway is a redundant logical device. You can feel pretty secure about it, but it doesn't allow its availability zone specific, so data center specific. So you should have a NAT gateway in every single availability zone. And that's what you're going to use. It's going to use one public IP address for the life of the gateway. What's it going to look like? It's going to look like this, the following things. It's going to look like you got your users in a private subnet. They have a default route, which is if you don't know where to send your traffic, send it to the NAT gateway. And then on the NAT gateway, your traffic will be sent to the internet. So let's talk about the next things, elastic network interfaces. I hate the term. Elastic IP addresses, I really hate that term. So now we're going to deal with elastic network interfaces. What is it? It's an interface, a network card that's sitting in your virtual machine. You've got a virtual machine with 3 interfaces, 3 subnets. So when you start a system, they assume your system is going to be connected to the network, and it always comes with a network interface, like your Ethernet card, your virtualized Ethernet card. That's a network interface. The default one's going to be ETH0, like on pretty much most Linux and Unix systems and routers. But if you want, you could create 2 of them. One way you can create 2 of them is if you're creating a Bastion host, which you should never do. And my team has made a video on this channel of why you wouldn't use a Bastion host or a jump host, because it's the worst idea I've ever seen. And I've never seen anybody do it in reality, except I almost got fired for trying to create one 20 years ago because I wanted to create a backdoor for myself into the system. And the security people had it, and they're like, Mike, you and Greg did this. You'll be fired if you ever do it again, because it's such a dangerous thing. So you won't see that on the certification courses, except that in Azure, but their service is totally different. So you might need 2 network interfaces. You got a server and 2 subnets, and you don't want to use the routing to routing. You want to do it on the server. It's called the dual home system. Elastic Network Interface means nothing more than the Ethernet card sitting in your systems. Now, the next ridiculous term that AWS made up is something called an elastic IP address. What is it? It's a public IP address. That's it. It's a public address. If you go to me or the chief operating officer and I say, I've got an elastic IP address, they're going to say, please leave the room. If you say this needs a public IP address, they're going to say, thank you, Mike. So an elastic IP address is a public IP address. And here's the way it works. Amazon maintains a pool of public addresses. They own them. When you need a public IP address, you borrow it from the pool. You take it and you use it as long as you need it. And when you're done with it, give it back to them and everything is good. So this is seriously simple and elegant. Otherwise, if you need public IP addresses, wow, you got to go apply for them. And with AWS, it's in minutes. So this is velocity. Velocity means agility. Agility means digital transformation. So this is a really great service with a silly name. Public IP address, elastic IP address. Elastic network interface, just a simple network interface. And we're really, all the noise, everybody's trying to rescue my cat from the thunder and lightning. So now let's look at our public IP addresses over here. We've got our systems. They have a public IP address on them. Each one will need one. In case if there was a load balancer here in front of the instance, the load balancer would need a public IP address. That's all we're really talking about. Okay, let's talk about VPC endpoints. Endpoints enable you to securely connect to systems across AWS. They give you the best performance, the lowest latency, the best security, and the lowest cost way to do it. Let me show you what would happen without an endpoint, which you don't want to use. Wrong slide. Here we've got your VPC and your object storage, AWS S3. Now, there's 2 ways you could get your data to them. You could send your data out your internet gateway across the internet, and it could come back into AWS. Now, you wouldn't want to do this for lots of reasons. You've now taken your private data and stuck it on a public network like the internet, which the best you can do to secure it is encryption, which is pretty solid. Now, when you're on the internet does not guarantee your traffic gets there at all. Zero. No guarantees whatsoever. So now you send your traffic to the internet. The internet's got latency challenges, and your traffic may or may not get there. So you got a security thing, which you got to encrypt, and you got the internet. Why it's worse? Amazon charges you to send data out to the internet. So now you're going to be paying large amounts of data transfer charges for the lowest performance and the biggest security risks. Why do that? You can create an endpoint. And what happens with the endpoint is almost as if Amazon's creating a virtual wire, which is really what it is. It's a pseudo wire between you and your object storage. So you get to ride the Amazon network. And can Amazon guarantee their network's performance? Yes. Can anybody guarantee you internet performance? No. So it's giving you better network performance. It doesn't have the security risks associated with going off the network. And it's cheaper. So when you can do something better, faster, and cheaper, you're always going to use it. So VPC endpoints are one of my favorite devices in the cloud because they enable you to build wires between locations, literally speaking, in minutes. That kind of agility promotes so much digital transformation. It's one of the reasons we love the cloud. So now you understand VPC endpoints. So let's talk about the kinds of VPC endpoints. There's going to be 2 that we're going to talk about. There's going to be gateway endpoints and interface endpoints. And they both have very different use cases. A gateway endpoint, we'll discuss first. Gateway endpoints are high-speed, high-security access to an AWS service. And how's it work? It puts a route on the routing table. Hey, to get to S3, go here. Brilliant, simple routing. So what happens when you create an endpoint for S3, a prefix list is created, and a VPC endpoint is created. Now your prefix list is going to look like that route on the routing table, and we'll adhere to a convention, PL-XYZZZZZ. And that's going to be seen in your routing table. And what will happen is you'll have a route that says, hey, to get to your object storage, go this way. Brilliant, simple way to do it. So let's think about gateway endpoint security. You can set up policies to limit it. But here's something. If you don't have a route to reach something, you can't see it. So we've got this guy Costas that's sitting in Greece. I'm in Florida, USA. Now, if I don't have an airplane and I don't have a boat, can I reach Costas in Greece? Can I swim across the Atlantic Ocean? No. I'll be eaten by sharks or die or drown or somewhere along the way. So I have no route. I can't visit Costas in Greece. Now, if I buy a boat, a big, beautiful boat, now I might be able to sail that boat from Florida to Greece, and I can reach them. If I jump on an airplane, I can reach them, but I can't visit Greece by just trying to swim there or walk there. So think about that in terms of routing from a security perspective in your gateway endpoint security. If you don't have a route on the routing table, you can't reach it. So don't put routes to things you don't want to reach. Now, we talked about the gateway endpoint being high speed to certain services such as S3. Now, let's talk about interface endpoints. Let's talk about them. Interface endpoints work differently. They're used to connect to, say, the EC2 Systems Manager, Kinesis, Elastic Load Balancer APIs, external services hosted by AWS partners or customers, etc., or in their own VPCs, and these work differently. When there's an endpoint, the interface endpoint is going to be local to the VPC. It's basically going to do the following. It's going to create a network interface or network card on your side and whatever you're connecting to, and they're going to be on the same subnet, which is really cool. So you're basically creating another virtual wire between you and them. And when you create the endpoint, AWS is going to create that virtual network card on both sides of it. And it'll give it a specific DNS name. So you can say cindythecat.cisco.com, for example, instead of just trying to remember an IP address. Now, the way these interface endpoints work is they use something called AWS Private Link. That's that virtual wire that I was talking about. It's basically a virtual private line. So how does this work? It works via the following. Let me show you this very quickly. Here you've got two sets of systems. And in these two sets of systems, what you actually have here is a customer and another customer across two VPCs. When we create this interface endpoint between these two VPCs, what we're talking about over here, it's like we created a private wire. Want to know something else that's cool? Since all organizations actually use the same RFC 1918 address space, when one company buys another company, we often have a problem with IP addresses. But with private link or interface endpoints, the system will automatically translate one address to another. It'll use network address translation. So if customer A is in the 172.17 network and customer B is in the 172.17 network, private link will automatically do the NAT or translate it, so we've got full communications. So private link is really nice. So we will talk about VPC peering in a minute, but what's the difference between private link and VPC peering? They're very different and similar at the same time. Private link is Abigail over there, Chow over there. They want to talk to each other. They create, they do VPC peering, and now everything Chow has is available at Abigail, and everything Abigail has is available at Chow. Now, if they're the same company, that might be highly desirable. But let's take another situation. Let's say now that Chris has a cat food company, and Abigail's a customer of the cat food company because she has a pet shop. I have a pet shop too, and I'm a customer of it. Now, do I need to know what's going on in Abigail's pet shop? Obviously not. We're competitors. Do I need to know everything about the operations of Chris's cat food manufacturing business? Of course I don't. But what do I need to know? Whether he's got my cat's favorite food and my customer's favorite food. So with Private Link, I can set it up that we can only access many services. Exactly what I need and nothing else. So we've got better security with Private Link. We'll talk about VPC peering in a minute, but understand this. VPC peering is really limited. You're allowed up to 125 peering connections, which is nothing, zero, nothing. Private link scales much better, almost to the limitation by the throughput of your load balancers in your server. Well, not exactly, but almost. So you're talking about a much better service for some use cases, but not others. Private link solves the problem, as I told you, of overlapping address spaces by doing that. But private link is unidirectional, which means tighter. I connect my pet shop to Chris's cat food manufacturing company. I can see whatever he shares with me, and he can't see any of mine. Nothing. Now, if I need him to, I can create a bidirectional private link connection, and then we can share data. But by default, it's secured in a single direction. So private link is really, really cool. VPC peering is bidirectional. Bidirectional. So, Chris, I'm thinking of going to VPC pairing. Where are we time-wise?
We need to go to questions.
Okay, let's go to some questions. What does PCX stand for? Absolutely nothing that you need to think of in any way, shape, or form. It was just something that we made up in the routing table to make a point. Good question, though. Why does adding foundation certificates to your resume make you unhireable? Here's the reason. I need an airplane pilot, and I want to hire an airplane pilot. Now, the airplane pilot's resume says dog walker, psychiatrist, neurologist, electrical engineer. And when you see that person, you say, I don't want that guy as my airplane pilot. I want an airplane pilot. When an architect whose design presents and sells has a bunch of engineering certifications, you can't hire that person to be an architect because they look like an engineer. And I'll tell you time and time again, we get people that can't get a job and they've got all these silly associates, like the DevOps associate, the SysOps associate, the developer associate, and then apply for a job where it's design, present, and sell. The hiring manager looks at it and throws it away. By comparison, if the resume shows they're a system designer, it shows leadership skills, sales skills, presentation skills, system design skills, then they get hired. So it really comes down to it. It's your brand. It's your brand. When engineers want to become architects and they go on interviews and they ask them business questions, the engineers don't know how to answer them. When an architect goes in an engineering interview, they can't answer those deep engineering questions because it's different skills. Now, being, for example, trained in somebody else's job has nothing to do with your job. And that's really what the problem is. We see people doing the worst advice ever. Somebody told them to be a professional, AWS certified solution architect professional, which you could do easily. Take a DevOps associate, a SysOps associate, a cloud developer. Here's the problem. Cloud developer is a software engineer certification. SysOps is a maintenance person's certification. DevOps is a DevOps certification. When somebody has that, you know what they are? Not an architect. So don't get 1,000 silly associate certifications. Get one professional certification in your career. Maybe one more to substantiate your career, and then develop the skills for your, not somebody else's. I can just tell you this. I've interviewed 1,000 AWS certified people. Most had at least 4 certifications, and 0 were hireable without special training. Build your brand, not somebody else's. A VPC is a virtual appliance? No, it's a virtual private data center where you put your stuff in the network. Of course, everything in the cloud is basically a virtual appliance. So it's not, the cloud is nothing more than any other 40-year-old network and data center that's been virtualized. It's the same thing. And your VPC is your virtual private data center. Abhijit, I have a quick question. Once the organization migrates from on-premise cloud to the cloud, the migration is done. Do they still need engineers? Yes, engineers will maintain it. Now, the reality is this: in most cases, you're going to have a cloud architect designs it, a cloud engineer that's going to build it, and then it's out of the cloud engineer's hands and it goes to sysops or maintenance people. And that's why those sysops or maintenance people are the lowest paid people in the technology chain. They typically work in the operations center. And that's why I don't recommend people getting that certification unless they love operations. For people that love operations, it's great, but not if you want to be an architect. And truthfully, if you want to be a cloud engineer, it's not the best place either. Cloud engineers are usually part of the build team, but some organizations will have cloud engineers as part of the main team as well. And that's why so many of us work for consulting companies, etc. Lars Habits, Mr. Mike, how many cloud engineer related certifications are too many? 3 would be optimal. Meaning, one can be the Certified Solution Architect Professional, which is an engineering, not an architect certification. Maybe one is a CCNP, which is a good networking certification. Maybe another one's a Terraform one for a cloud engineer. How do we choose VPC Peering over VPC Interface Endpoint? If you need to exchange everything, use VPC Pairing, and I'm going to talk about that. If you only want to exchange a little bit, use Interface Endpoints. If you need a lot of connections, you can't use VPC Pairing, and I'll show you why. Coming back. For a more fault-tolerant system, which I recommend VPC Pairing or Transit Gateway, neither. I recommend 2 or more clouds for a fault-tolerant system. Whether you're using VPC Pairing or Transit Gateway is irrelevant. It's the path to the cloud will go down. And the VPC and Transit Gateway isn't exactly used for this. Transit Gateway is going to be used for, I'll show you exactly what Cloud Hub and Transit Gateway are used for coming up. Why I use a NAT gateway over the old NAT? Because AWS told you so. And just continuing the NAT, the old-fashioned NAT instance. Otherwise, the NAT instance is probably a better approach. Do sysops people need a background in coding? Absolutely. They're maintenance people. And maintenance people write bash shell scripts and Python scripts to automate. Architects don't code, so we don't need coding. If we did, I would have done a different job the last 25 years. You're looking to buy the book, Routing TCP/IP by Jeff Doyle. It comes in 2 volumes. Do you need both? Yeah, absolutely. You also need to read the book, Internet Routing Architectures. You probably should read Stephen's TCP/IP unless you take our course. But Jim, if you were our student, what I'd recommend you buy, and I think by your name you are our student, which means you've gone through our training, I'd recommend the book Internet Routing Architectures. And the first, if you want to get extra bonus, the first Routing TCP/IP volume 1, because we cover so much of those other things. But if you're not under our training, yeah, you need them both. Good questions. Okay, if you can do this, give me a hashtag, free full AWS course. Just like the title, free full AWS course. If I see that, I know you guys are awake, alert, and oriented. I'll wait to see some of them come in. And if I see some of them come in, I know you guys are getting there. If you just joined us, please download the free book. And please sign up so you can get the free hands-on demos. Make sure you subscribe because we're going to be producing a lot of content to really help you out in your career. Plus, you know, my team's constantly online. Follow me on LinkedIn. We're constantly producing things, art magazine articles, really anything we can to help you truly build your career, because I want everybody to have the best careers ever. Gustavo, free full AWS course. Brian, free full AWS course. Faris, free full AWS course. Leonardo, free full AWS course. Fantastic. Ashley, free full AWS course. Terry, free full AWS course. Mufaz over there in Nigeria, free full AWS course. You're currently working in the infrastructure support project and want to move the cloud domain. How should you prepare? I have no idea because I don't know which career you want. Every career determines different preparation. You tell us your career and we can guide you, but It's kind of like an airport. Which plane do I get on? You want to go to Istanbul? You go on one plane. Want to go to London? Go to another plane. Want to go to Athens? Go to another plane. Erwin's free full AWS course. And in the morning, tomorrow morning, I will answer career questions. Leonard Lash, free full AWS course. Alexandra Kalispera, free full AWS course. Martin, free full AWS course. Lars, free full AWS course. Brian Mott, free full AWS course. Clouds to the moon. I think I know who you are. What a great photo. Free full AWS course. AJP, Uran, thank you for your service. Free full AWS course. Sam, any introverts that here became a cloud architect? I'm an introvert. You won't know it, but I'm an introvert. Tracy May, free full AWS course. Eva Doike, free full AWS course. And it's really funny. One day, Alvin DaCosta, the VP over NVIDIA, comes up and he's like, Mike's the biggest introvert I've ever met. And everybody went silent. They're like, really? Him? He's like, yeah, Mike had a lot of training. Effie, free full AWS course. I'm loving this, loving this, loving this. Coach Cleats, free full AWS course. And Mick B, good to see you, free full AWS course. So cloud certifications don't line up after each other. They don't grow up as one cert leads to cert 2. No. How can you take a certification and somebody else's career and have it line up? That is insanity by certain certification providers. And I came out of retirement because of the bad advice from those providers. Here's the thing. You can do this AWS Certified Solution Architect Professional exam as your first exam if you want to. And I've got lots of students that do it. Take the exams in your career. Here's the problem, Theo. I'm going to make it very clear. The hiring manager's perspective as an associate certification is almost ready to interview, but not really. Almost ready for the job, but not really. They view it as the kindergarten. So if you've gone to kindergarten for 5 times, does that make you prepared to do a college graduate work? Of course it doesn't. But if you go to college, you're prepared to do college work. Going to elementary school 4 different times does not help you. So when we do this, and Theo, I'm going to tell you, I've got people that have been on 30 interviews before that won't get hired. And I say, can I take this silly sysops, this silly DevOps, this silly cloud developer off of your resume? And they say, Mike, I worked hard for it. And I said, no, you worked real hard for it. Spent 9 months, which was the equivalent of $120,000 of lost earnings while you did these certifications. Can I take them off your resume? Yes, Mike. They go in an interview and they get a $250,000 job because they're clear as an architect. Why is a Mercedes worth a lot? It's got a strong brand. Why is an Apple worth a lot? It's a strong brand. Does Mercedes have the brand of, this thing, or is it a performance car that lasts forever? We got a strong brand. Apple's brand, fun, cool, and cute. If it wasn't, they couldn't charge 3 times more than anybody else. It's brand. What brand do you want to have? Do you want that Apple brand, that Mercedes brand, or do you want to have the confused brand? I'm a little of this, I'm a little of this, I'm a little of this. I'm not good at anything, but I can do a little bit and I know a little bit about everybody else's job. That's the reason why. So no certification is going to get you hired. It's knowledge that gets you hired. And what you need to know is not covered in certification. I'm trying to give you a lot more than certification. This is no certification course by any stretch of the imagination. It's mostly certification, 3/4 certification, and 25% what you need to know. Don't go to kindergarten 5 times. Go to elementary school, high school, college, in your field, not somebody else's, and then you're cloud hired. Okay, let's get back to the content. I'm glad Chris popped it up there because it's the biggest problem we actually see in people getting hired is they're following the certification provider's advice. And why is the certification providers doing? Because they can't get you hired. Take 1 course, you don't get hired. Take another course, you don't get hired. Take a 3rd course, you don't get hired. Take a 4th course, you can't get hired. And then you send them a Slack message. Why can't I get hired? And they pause your notifications. I have a lot of students from these programs in my program, and they're getting hired every day after we fix their resumes and retrain them. So what is VPC Peering? VPC Peering is a method to connect multiple virtual private data centers together on the cloud. VPC Peering provides a non-transitive connection. I will show you what that means. And VPC Peering uses private IP addresses for communication. Good news is your inter-region traffic is encrypted. So what did I just say? I just said that VPC Peering is non-transitive. Oh God, what is this? What is this? What is this mean? I'm going to make it very clear for you. Here's what it means, because I didn't understand it when I first became a network engineer. Here's what VPC pairing is. So let me get my graphic set up. We'll whiteboard it out because it's very important for you to understand it. So over here, let's just say we've got this special little girl over here. We can probably recognize her. That's Abigail's beautiful cat named Noni. We're going to do some VPC pairing. Now this is Noni. She has a cat food business and she's very, very cute.
I'm sending you a new picture of Sunny.
Perfect. Can you send me a new picture of Sunny right now via Slack so I can do it? While you're at it, I'm going to now put the extreme business owner over here, the second love of my life, my cat Cindy. She's going to be the business owner. This is Cindy. Oops, I put it in the wrong screen. Didn't do that right. I can't remember which monitor I'm working on. So now over here we've got the Queen Bee. This is the CEO of CindyTheCatFood.com. And now while we're at it, Chris from my team is going to send me a photo, or we already did, of SunnyTheCat.com. Chris, can you Slack that to me or text it to me?
I Slacked it to you.
It's not showing up. Okay, let me check. Oh, beautiful. Okay, so I've got Chris's cat, Sunny, over here. Another very beautiful lady. We all have girl cats here. So let me show you what this is by non-transitive. So over here, okay, we've got Sunny over here. So now we've got three beautiful little girls. Although Sunny's not super young, but she's very special and very beautiful.
And she's not too little either.
And she's not too little. She's a Maine Coon. So let's pretend this is Cindy's VPC A. And now we've got VPC B and VPC C. So what does VPC pairing, meaning transitive versus non-transitive? So now we've got a connection between Cindy and her girlfriend, Noni. They're good friends. She's not the best of friends with Sunny the cat. Sunny the cat is a really great cat, but she doesn't love other cats. But they still talk periodically and they text each other on their phones. So here's what happens. Cindy the cat starts a business creating cat calendars. And Cindy reaches out to her two friends. Hey, Noni the cat, up in the upper right-hand corner. I want photos of you for my cat calendar. And at the same time, Sunny the cat says, I'm feeling left out. I got beautiful orange fur and I want to be on the cat calendar. And Cindy says, yeah, that's why I reached out to you. I want you on my cat calendar too. Now, as it stands right now, if Noni sends her subnet information, and I'm going to put it on here just so you can see it, so you guys understand it, because this is really what we're going to be talking about on a lot of things. 192.168.0.0/16. That's Cindy's subnetting information that she needs to send, or that's Noni's subnetting information. And where does she need to send it? Let's make sure you guys can see it. She needs to send it to Cindy. It's going to be really hard to remember the boss's name, so we're going to put our Cindy over here. And yes, Cindy is the boss. Cindy tells me what to do, and I just listen to her do it. She points to the door, I know to open it. Cindy's the boss. Now, at the same time, right over here, we've got Sunny the cat over here. Let's put her subnet over here. Sunny the cat, because somebody did very good IP addressing for them, she has a CCIE buddy. She now has the subnet that she's sending. Here's the difference between transitive routing and non-transitive routing. When Noni up here in the upper right corner sends her 192.168.0.0 to Cindy, and Sunny the cat sends her 172.16.0.0 to Cindy, if Cindy's quiet and like a secret agent and she says, Noni, you don't get to learn about Sunny's information, and Sunny and Sunny, you don't get to learn about Noni's information. What happens is Cindy the cat over here, Noni the cat, you don't know what just happened, cannot talk to Sunny the cat through the network. That's called non-transitive routing. And keep that in the back of your mind. That's non-transitive routing. Now, here's what transitive routing is. Noni sends her information to Cindy. Here's how you reach me. And then Cindy says, hey, Noni, I learned some new information. And with this new information, this is how you reach Cindy. And then Noni says, hey, tell Cindy, please tell Noni how to reach me. And by exchanging information, now Cindy gives the information to Noni and Sunny. Now they can all talk to each other. So by default, when we get to VPC peering, when I say it's non-transitive, any information from the cat received in the upper right corner that gets sent to Cindy in the box will not be sent to Noni, and that's why they can't reach each other. But with transitive routing, here's what occurs. Noni, the cat in the upper right-hand corner, sends the message to Cindy, and then Cindy sends the routing information to Sunny. And then Sunny gets Noni's routing information from Cindy and now can reach Noni through Cindy. So that's really what's going on here with transitive versus non-transitive routing. And there's going to be a way to break the rules too, which we'll get to next. So to put it another way, VPC pairing is basically when you connect two virtual data centers together. Now let's get in the meat and the nitty-gritty of where it gets complicated. VPC peering is, and thank you Text47, I love using cats. VPC pairing is not transitive. Now you know what that means. Okay, so a hub and spoke architecture will not work unless we break the rules of non-transitive peering, except in this environment, which we'll get to next. So what we have to do in order to have transitive routing is either break the rules, which we can do. And I'll show you how we break the rules. And what did I learn how to break these rules? About 25 years ago, because this is what we do in iBGP pairing, which is the same thing. Same problem, 40-year-old problem, and we're using a 40-year-old solution to solve it. So let's talk about when hub and spoke actually works, standard. Let's look at this environment right here. In a non-transitive environment, VPC A can talk to VPC B, and VPC A can talk to VPC C, and VPC A can talk to VPC D, VPC A can talk to VPC E, VPC A can talk to VPC F, and VPC A can talk to VPC G. But B can't talk to C can't talk to D can't talk to E can't talk to F, and F can't talk to G. Now, if we enable transitive routing, then everybody could talk to everybody. And we're not going to get there yet. We're going to just deal with this for right now. So where does the problem occur? And how do you make it work in non-transitive? You've got two options. Option one is to fully mesh your peers. Now look at this. If VPC B connects to C and C connects to A, everybody's got a connection to each other. Can B talk to C? Yeah, over its direct connection. Can VPC B talk to A? Yep, it's got a peering connection there. Can C talk to A? Yes, it can, because there's a connection. This is fully meshed. Fully meshed. Now, why is fully meshed a problem? Everybody get out your calculators. Get out your calculators for fun. Now, the formula is as follows. Remember, we can only have 125 VPC pairing sessions. So the formula is n times n minus 1 divided by 2. Okay, so let's say you've got 15 VPC pairs. We're going to do 15. We're going to do 1, 5. I'll do it with you. Times 14 is 210 divided by 2. So for 15 pairing sessions, we've got 105 connections because it's n times n minus 1 divided by 2. What happens if we've got 20 connections? 20 times 19 equals 380 divided by 2. 190. Wait. AWS only allows you 115 or 125. Is this a problem? Yeah. You've got 190 that you need for only 20 sites. What about organizations that have 1,000 VPCs? It's common. How are they going to make it work? Well, they can. Yeah, so what do we do instead? In BGP, here's what we do. We use something called a route reflector. What does a route reflector do? Well, here's what a route reflector does. A route reflector says, Cindy, please take in any routes that you learn via Noni and break those rules in non-transitive routing and send them to Sunny the cat in the bottom right. And Cindy takes Sunny's routes and hand them to Noni so they can all talk to each other through me. That's what a BGP route reflector does. So now you know how we network architects solved this problem 30 years ago. Now, AWS is a virtual network in a data center. So virtual network in a data center. Is there any network technology that's 30 years old that makes this work? Yes, a BGP route reflector. So AWS has two equivalents of the service. They have something called Transit Gateway and something called Cloud Hub. To we network architects, they are identical. To someone that only knows certifications, they're very different. Here's the thing. Cloud Hub is a route reflector type technology that works with only VPNs. Transit Gateway is another route reflector that works with private lines and as well as VPNs, etc. So pretty much the same thing, just how you use it. So now you got an organization that wants to do a lot of Vpc pairing. We turn on Cloud Hub. Cloud Hub enables multiple sites to communicate with each other by breaking the rules of transitive and non-transitive routing. So instead of using all that IBGP nonsense, which is realistically what we're talking about, IBGP, that non-transitive routing, we use eBGP connections per system, and we don't have transitive routing problems. Now, I've showed you with my cats, and I prefer to use the cats of Go Cloud Careers, but here's a professional drawing that we have for you. You've got a Boston system, a Washington network, and a San Francisco network. They all do the VPC peering to Cloud Hub, and now everybody can reach everybody through Cloud Hub. That's all it is. It's a way to create a hub and spoke transitive routing network. So Cloud Hub enables hub and spoke transitive connections. It uses eBGP, so each place has an eBGP connection, and we get out of the non-transitive routing. Now, here's the good news. Because it's BGP, we can implement any kind of security policies we want. Anything we want. Filter this route, don't filter this route. We can optimize, choose this link. It is beautiful, beautiful, beautiful. Now you know it's Cloud Hub. Hey, wait, here's the Transit Gateway. Whoa, what's the difference? Nothing. Other than now we can use private lines in addition to just VPN. Same identical technology. Okay, so let's talk about a few more things in the VPC access control lists. For any of you networking people that know networking, and if you're an architect, you need to know the network in the data center because that is the cloud. All we do is take stuff from the network and data center and move it to the cloud. You may, if you're a network engineer, or if you're a network architect, you've worked with them in your youth possibly, or if not, you designed them. We can have a packet filter that says, allow traffic from this subnet to this subnet. Or we can use an ACL to say, this subnet doesn't get this traffic. That's all it is. We create an access control list. Now, you'd think that the cloud providers would just call it an access control list, but nope, they don't. They call it a network access control list. What does it do? Protects traffic from your subnets based upon a policy you make. So it keeps unwanted traffic out of a subnet. A security group keeps unwanted traffic out of a host. A network ACL keeps traffic out of a subnet. People always confuse this. Network ACL, protect the subnet. Security group, protect the host. Keep it like a server. Now, when you're dealing with packet filters, access control lists, in general, Azure, Google, AWS, Cisco, Juniper, or any other routing device for that matter, all ACLs or access control lists, the default policy is to deny. So you have to permit what you want through, otherwise it will be denied. Now, most access control lists are processed in order. And they make a decision and then they're done with it. So the order matters. So the default policy is deny all traffic. Access control lists are not like a firewall, meaning they're not stateful, they're not monitoring the connection, so you're going to have to apply them in both directions. So you need to specify the source and destination address, the protocol and port number, like an extended access list on a Cisco router or every other access list in the world. Now, I told you the order matters. I'm going to work through with one, a bad one, and so you can figure it out. In this particular ACL, what do? We have inbound and outbound ACL. Rule 1, deny everything. Rule 2, allow TCP port 80 or web traffic. Outbound. Rule 1, deny everything. Rule 110, allow web traffic. So let's think about this over here. What's the first thing that happens? Packet come in and hits deny all traffic and it gets tossed away. The packet doesn't even make it to rule 2, so nothing gets through, ever. Want to hear a secret? You don't need to ever put the denial traffic. The implicit deny is there. It denies unless you tell it otherwise. So how do you do it correctly? Rule to 110, allow TCP port 80. Rule outbound 110, allow TCP port 80. Now don't go rule 1, rule 2, rule 3, rule 4. I promise you're going to get yourselves in trouble. You are going to need more rules than you ever can imagine. You want to block one subnet, and all of a sudden there's a hacker in China that comes in. You want to block that person, but not all of China. Then all of a sudden you get a hacker in Ukraine, and you want to block that. Then you get a hacker that's sitting in Saudi Arabia. Then you get a hacker in Philadelphia. Then you get a hacker in Palm Beach, and you want to block the single IP address. If you don't leave yourself space, you won't be able to move around. So maybe 100, 110, 120, 130, or bigger spaces. Because I promise you, you will need to apply so many more access control lists than you will ever dream once you find out ahead of time. So let's look at another example. And I color-coded this. And why did I put access lists and security groups in the same subnet with different colors? Because everybody messes it up, and they're test questions, and people don't understand it. And I want you to understand it. We use an access control list to keep unwanted traffic out of a subnet. And then whatever passes the access control list hits the subnet where the systems are. And we use a security group to protect the host. Which do you need? Both. Because these two together are part of the program. Just part of it. So what's a security group? It's a host-based firewall for the systems. It protects the servers. The servers. A well-deployed security architecture will have both, and many, many more things. Now, security groups are stateful. Stateful. Which means they monitor the connection. I know most people don't understand stateful, so I'm going to make it real clear to you, real fast. Because people are often confused by this. Let's go to our network environment real quick. Actually, we're going to do it on this one. So in this particular case, Cindy the cat's the only user of the system. Sorry, everybody else, you guys are all beautiful, but you don't make it for this exam. We'll be on the next one. So in this case, we've got a user. Now, Cindy the cat's pretty smart. I'm going to put her name over here so we know who she is. Now, Cindy the cat is an expert troubleshooter, and she loves to use her daddy's computer. She likes to power it off with her paws, through the Ethernet cable. She's truly an amazing lady. But there's this website that Cindy wants to go to. She loves this website. Cindy decided she wants to become a cloud architect. So what does she do? She goes to this beautiful website, www.gocloudcareers.net. Cindy wants to get her first cloud architect job. She heard that if she becomes a cloud architect, she can afford as much tuna, salmon, shrimp, and scallops, and she can have 10 servants, not just 2, taking care of her needs. So Cindy wants to become a cloud architect. So here's what happened. Now, Cindy's dad is security obsessed. I'm sorry, .com. I don't even know how I put that over there. I don't even know what I was thinking. So Cindy wants to go to www.gocloudcareers.com to get her first cloud architect job. But her daddy, Cindy's daddy, is a security obsessed nightmare. So her father has a big firewall sitting in the house. So I want you to understand this, and out here, let's put a hacker over here. So Cindy wants to go to the internet, and Cindy enters in her browser, www.gocloudcareers.com. So Cindy's packet originates over here, and Cindy's packet makes it through the firewall. And this is what we mean by stateful, and it goes all the way over to GoCloud Careers. Now, my students will tell you that Cindy sends a synchronization number to open a TCP connection with the website at www.gocloudcareers.net. And then what's going to happen is the website's going to send an acknowledgement to the SYN, and it's going to open a SYN or a synchronization message to the with Cindy. So here's what happens. Cindy goes to the internet, the firewall tracked that she went to the internet, and now the website is responding back to Cindy. And it says the website is going back to Cindy, allow the message through because Cindy initiated the connection. So her traffic goes out and is allowed back. That's stateful. What's the state? The firewall's tracking what happened. Cindy sent something out. Now let's take the exact opposite example. I got a hacker sitting outside the firewall and they want to hack into Cindy's computer. But Cindy's data is security obsessed. So the hacker tries to get to the firewall and the firewall says, no, you're an evil hacker. And then Cindy's dad behind the firewall has an intrusion detection, intrusion prevention system. And then Cindy's dad has an access control list, which protects the subnet. And then Cindy's dad has a security group on everything else, of the servers he has. And then the servers are hardened. So that's what we mean by stateful. I wanted you guys to all understand, what do we mean by stateful? So let's go back to the security groups are stateful, which means when a packet goes into that server, the security group says this traffic is allowed in, it's allowed out. And that's the reason it's applied in one direction. Stateful doesn't mean needs to be applied in one direction. Stateful means you're tracking the connection. So that's pretty important to understand. So security groups allow rules only because the implicitly deny. And all rules are evaluated. Ooh, this is different, like a firewall. So I got this, my friend's buddy's cat that's on my network. And my buddy's cat's IP address is 192.168.1.1. But this cat is evil. This cat likes to hack. So I have a security group rule that says deny 192.168.1.1, but allow 192.168.1.0/24. And that way all the other cats in the subnet can get in except for the evil hacker. That's what we're dealing with here. So we'll talk a little bit about tuning networking performance. And unfortunately, we're not going to be talking about really cool stuff like routing performance. We're going to be talking about what AWS considers networking performance. And it's all going to start, which means we're going to cover the following things. Placement groups, single root IO virtualization. Trust me, we'll make that simpler. We'll cover the Elastic Fabric adapter. We'll cover AWS Route 53, and we will cover an Elastic Load Balancer. Let's start with the following. Placement groups. So if you really need low latency computing, you're going to do it in your data center, not the cloud. But what can you do to improve it on the cloud? Where you put your server. So I want everybody to understand the following. Actually, you know what? Before we do this, maybe we should get into some questions. So let's see if there's any questions. Any questions I need to address, Chris? What's the difference between a NAT instance and a NAT gateway? Well, a NAT gateway basically does the NAT and provides the internet connectivity at the same time. A NAT instance is a virtual machine that you also need an internet gateway to connect it to. AWS is basically saying don't use the NAT instances, and it's going to be disabled at some point soon in the future. So use a NAT gateway. But good question. You can't do this in a pre-recorded PowerPoint slide with audio ask questions. That's what we do with bootcamps for free. Chris, you can go to the next one. You can use a network ACL for the block or a specific address. It's up to you. And you'll constantly having to do IP addresses. There's always going to be one bad actor that you need to prevent, but you still want to allow the same subnet. So how could you block a host? You've got a /32-bit subnet mask versus a /24 or /16, etc. McB. At the network ACO level, what is meant by the NACL and specs all rules that execute that? We said that with regards to security groups. So I want you to think about this. If you've got a network ACO, rule 1, deny everything. Rule 2, permit everything. Everything is dropped by rule 1. Now, a security group is different. It'll apply everything. So rule 1, block 192.168.1.1/32. Rule 2, permit 192.168.1.0/24. It means it's going to follow, it's going to check both rules before it discards the packet. And that is a great question, McVeigh. Excellent question. Who else has questions? I think I saw a few pop in there. Dylan Williams. How much do you consider securing an architecture? It is absolutely critical. Do you have to tell the engineers how to harden it, or is it a higher perspective with just port security? Look, port security doesn't scratch the surface of security. It doesn't even begin to scratch the surface. The architect designs the big picture. Here's why engineers can't design the security. I'll make this real clear. Engineers must do detail-oriented work. Architects need to do big picture work, which is why you can't be an engineer and architect at the same time. And security engineer is going to be an expert at configuring that firewall. They're going to know how to make that firewall sing, add this rule, add that rule. They are a really, really smart person for that. They're expert. They're the most tech people. The architect's going to say, look, I need to secure this enterprise. I'm protecting $40 billion of assets. Therefore, I'm willing to spend a lot of money. Now, then the architect asks the business, the value of the assets, the value of the intellectual property, what they're trying to protect. The architect will then say, wow, this is critical security. At your data center facility, you need to hire armed security where your routers are attached to the cloud. At the edge of your network, you need a firewall. Well, we can't use AWS WAF because it's not good enough. We need something that's adaptive in nature. We need to use a firewall from either Palo Alto, Cisco, Fortinet, or Checkpoint. Now, those firewalls that we get from the marketplace are virtual appliances, so they're not high availability. So maybe we use a network load balancer before it. What if they breach the Palo Alto firewall? Maybe we should have a Cisco firewall behind it. Again, another network load balancer, 2 more virtual firewalls. Wait, do we need some intrusion detection and intrusion prevention in our system? Probably. Okay, another network load balancers, 2 sets of intrusion detection, intrusion prevention. Now let's protect the subnet. We got this security group. This network ACL, we use it. Now let's put a security group to protect our server, but now we got a server. What do we need to do to lock those servers down? We need to disable the unnecessary ports on that server by shutting down services. We need some anti-malware protection on that server. We need to patch that server. And we need to do some other hardening of that server, maybe some anti-malware, etc. Now that we're done this, Dylan, we still need some form of encryption on our network. What's a good form of encryption to use? Now that the user passed all these things, and we're talking about our DMZ design, etc., do we need an identity access management platform so we can determine who the users are? Do we use Active Directory? Do we federate it with something else? That's architect work. Then, we got all these logs coming in. So we take these logs and put them into something like a Kafka, and then put them into something like a Tabula so we can visualize what's going on in our security system. Now we got these logs. Do we store these logs in object storage? Do we then run a machine learning application on the object storage, etc.? Now, do we need to train the people for anti-malware, anti-phishing? Do we need to write a security policy? This is the architect work. Architect work is big picture. Engineer work is how do I configure that firewall? So Dylan, I like to say this as an example. Tonight, I want you to go outside and look at the sky. When you see the whole sky, that's what an architect needs to look like. The big picture. We can't afford to get touched close to anything. Now, I want you to take a telescope and zoom into the moon at 200x. What are you going to see? Part of the moon, and you'll lose the whole sky. The engineers need to be detail-oriented to do their jobs. Detail-oriented to do their jobs. And the architects can't afford to be detail-oriented because the second you're staring at that moon, you miss the sky and you create an outage and you get fired. So no, the security professionals don't get antsy. So Dylan, why is architecture a team sport? It's a team sport. Nobody designs an architecture on their own ever. We architects go to the customer, we find their business requirements. Then next, what do? We go back to our company and we reach out to the EVPs and the SVPs, potentially the CEO, and I say, I need 50 people on this team. I need 2 security architects and 1 security engineer. I need 3 network architects and 2 network engineers. I need a big data architect, etc. I need a database architect. I also need some cloud engineers for their detailed engineering perspective, 3 DevOps engineers, and a couple of application architects. And together, the cloud architect leads the design. That's why cloud architects need so much leadership skills, executive presence. If I had a person that was a doctor, just a doctor, and knew nothing about tech, Dylan, and I had a really strong engineer with 20 years of experience, and now was the architect. And the doctor who knows nothing about tech could get 10 global network engineers from Cisco, 10 security architects from Palo Alto, Check Point, and Fortinet, 3 big data architects from IBM, and some storage architects from Dell EMC. And he or she could manage all those people to create the design. And he brought in 50 experts that each had 20 years experience. He has 1,000 years experience on that. And he knows nothing about the tech. What's his design going to look like? Brilliant. Now, on the end, you got an engineer with 20 years experience that's used to focusing on one thing. What can they design? Nothing. Because it needs a team. And that's why people hire engineers to be architects. That's the reason it's so much leadership, executive presence, communication skills. And that's when we have engineers with good experience. We love that. We have to retrain them from scratch to be an architect. And that's when we get a medical professional, we train them to become an architect too. It's just learning the right skills. Now I give an example of somebody that doesn't know the tech. Now imagine a person that actually knows the tech and understands how to design it. That's the cloud architect. And that's why they're so highly paid, because they're coordinating everybody else. I know we should probably get back to the content, but Dylan, you've asked some good questions. Good questions. So let's talk about improving network performance on the cloud. You've got a couple of options. Imagine this. You can't get faster than the speed of light. So if you need a low latency cluster of servers, if they're separated by 1,000 miles, you got latency. If they're in the same rack, you got less latency. If they're at the same server, you got even less latency. So we have 3 ways that we can cluster our systems or move them together with regards to placement in the cloud to improve the performance. Each one has strengths and weaknesses, and trust me, some are good and some are horrible. We're going to start with placement groups. It's all about where you place them. Now, let's just say, assume you want high performance. High performance. Imagine putting all your systems in the same rack, or even the same server. That's what a cluster placement group is here. All your servers are plugged into the same rack, mostly often in the same server. Performance, that you're going to get on the cloud, really good, all on the same system. Where's the problem? They're all on the same rack or same server. The physical server dies, your cluster placement group is dead. The rack dies, your cluster placement group is dead. Your power distribution units on that rack go bad because the circuit breaker goes. Everything you have is dead. So in the technology space, we know 1 is none, 2 is 1, and 3 is greater than 2. Like the Navy SEALs say, 2 is 1 and 1 is none, because they're in harm's way and they know that stuff will fail and they got to work around it. So if you're going to use a cluster placement group, use 2 of them or 3 of them in different data centers, and then you'll be good to go. So high performance, high risk. So let's look at it. I had my one of my graphics people make it. Here you go. You got 1 rack, and all your systems are all in the same rack. That's your cluster placement group. Now let's talk about partition placement groups. These are getting a little better, but a little slower. Now imagine this. You take your systems and you spread them across the racks in the same data center. Well, what's the speed of light in the data center? Pretty slow, pretty fast. So 186,000 miles a second. I think that's like 300,000 kilometers per second. If I do the quick math in my head, it's pretty fast. So there'll be a little latency, but not worth talking about. So what is a partition placement group? You put your computer systems across multiple racks in the same data center. Wow, rack fails, you're good to go. Server fails, you're good to go. So much better availability. Now, where's your weak point? If the data center goes down, and trust me, that will happen too. But this is what this looks like. It looks like now, instead of using 1 rack, you've got your stuff spread across 3 racks. different circuit breakers, different cloud power distribution units, etc., and all is good to go. Let's talk about a spread placement group. If now you said, well, what if the data center goes down? What if I can spread my compute across multiple data centers? That's what a spread placement group is. So now you got some in one data center, some in another data center, spread across racks, much more availability, performance, and redundancy, but much higher latency. But it's a matter of choosing what's right. How do you design an architecture? What are the business requirements? What kind of latency can the application? I work with applications where a nanosecond is millions and millions of dollars a year of business difference. I work with other companies where it can be 5 seconds and who cares? It's all based upon the business requirement. But let's look at a spread placement group. See, you got data center 1, otherwise known as availability zone, data center 2, a different availability zone, and your stuff spread across the racks. So lower performance, higher latency, but a lot more availability. So it's all based upon what does the business need. Now let's talk about network performance. I think it's VMware that actually came up with this crazy name, and I love VMware. Single root I/O virtualization. What the heck does that mean? I'm going to make it very clear. If any of you have all worked with virtualization, in fact, I actually walked you through my VMware ESXi server the other day, part of what we were doing here. You may have noticed the following. You may have noticed that everything you have in there, virtual disk, virtual network card, virtual GPU, virtual everything. Well, here's the thing. Hardware is a whole lot faster than software. And not just a little bit, hardware is a lot faster than software. So what if you had a server that had 10 network cards in it, and you needed better network performance? Can you push that network card that's sitting in a PCIe slot directly into the virtual machine? Instead of using a virtual network card, use a physical one. Yes, and they call it single root I/O virtualization. It's also been called PCI pass-through. Hey, wait, what else can we do with this technology? While we're at it, if we wanted to do machine learning and we needed a GPU, and a physical GPU may be 1,000,000 times faster or more than a logical GPU, a virtual GPU, could we then push that GPU into that virtual machine from that PCI slot into the virtual machine? Yes, we can. You want to know what that's called? A GPU optimized instance. So people like me have been building GPU optimized instances for 20 years. Or not, maybe it's not that long, but for a while. Single root I/O virtualization is PCI pass-through. Take a physical card, stick it in the virtual machine, and call it a cool name. Single root I/O virtualization. I don't know how to make up these names. I like simple, plain language. I understand that. So now you know what it is. It's just a hardware network card going there. So now AWS came up with a new thing. It's called the Virtual Fabric Adapter. What is this? It's a better enhanced driver for non-physical network cards to improve the performance. That's all it is. So single root IOV, hardware network card, AWS Virtual Fabric Adapter, high performance software driver for the network. That's all it is. Okay, we're going to get into DNS and Route 53. What is DNS? The domain name system acts as a user-friendly name to an IP address. We could have an address. I'm going to do an NS lookup real fast so we can find the address. Actually, all of you, right now, open up a terminal window on your computer, because I'm going to show you what this actually is. I want you to understand it. Let me go to my applications and find a terminal window. Terminal window, command prompt, whatever you got on your computer. I want to see it. Just open it up right now. Oops, didn't need that. No, the wrong one. And I want everybody right now to do the following. Type NS LOOKUP. So November, Sierra, Lima, Oscar, Kilo, Uniform, Papa, if you want to spell it phonetically. And then type in www.gocloud careers.com. Everybody do it. Open a terminal window. And what do you see? You see a couple things. You see your DNS servers. Mine happen to be 8.8.8.8, which is Google's IP address. Then you get Go Cloud Careers, and you see an IP address that says 192.0.78.217. You also see our second web server. 1 is 9 and 2 is 1 and 3 is greater than 2. 192.0.78.137. Now, how many of you out there can remember 192.0.78.217 other than my wife with the photographic memory? Not many of you. But you can all remember www.gocloudcareers.com. So the domain name system translates a very simple user-friendly name to a IP address to make it human-friendly and human remembering for us. So how does this work? Let's say we all want to go to Amazon.com. We want to buy cat trees. I don't care what we like to buy. I buy a lot of cat toys from Amazon. Like Cassini's my princess. So here I am sitting on my browser and I type www.amazon.com. Now my computer sends a request to the DNS server. What's the IP address for Amazon.com so I can connect to it? The DNS server sends the address to me. And I've got the IP address now for Amazon. So now I go look at my routing table and I go, whoops, do I have a route to Amazon? No, but I've got this cool thing called the default route, which says go to my default gateway to go to the internet. And then my router does an ARP, who has the MAC address for this, for this IP address of Amazon. My local router does a proxy ARP, which says I've got the MAC address for Amazon.com, and then forwards my packet out to the internet. That's how this works, DNS. So that's how DNS works. I actually did this. I actually did an NS lookup in case you guys didn't want to do it yourselves. And I went and I did an NS lookup of www.amazon.com. You can see this 8.8.8 is my DNS servers. This is a backup 8.8, which is something called an Anycast server. We'll talk about that a little later. Then you can see this is actually the, the actual canonical name or the main name for Amazon. You can then see this is the name of the CloudFront distribution, which is 13.35.116.114. That's the actual IP address that we're connecting to for the CloudFront distribution locally from my home. And of course, Amazon has another kind of a record called the CNAME record that maps this really ugly name, this Delta 3 Alpha Golf 4 Hotel Uniform Kilo Kilo Hotel 62 Yankee November.cloudfront.com that you can see above the last prompt into something simple, Amazon.com. So now let's talk about domain names. Domain names can be broken down into three separate pieces. A host name, like Mike EC2 or www. And a domain name, and then a top-level domain. And we're going to talk about all these things. So www, host name, Go Cloud Careers, domain name.com, top-level domain. So when we deal with DNS, we're going to be dealing with DNS records. Now, DNS records, and I know this is a little techy and in the weeds, but we got to cover it. DNS records are called zone files. And when you make your DNS records, they're going to be done in something called DNS syntax. And the DNS syntax is going to be a text file that tells the DNS servers how to do their job. There's going to be something called a TTL, time to live. Now, that time to live determines how long the DNS server will carry out its actions without a refresh. So what does this mean? If you're going to be changing your addresses constantly, then you're going to need a short TTL because you want your systems to refresh quickly. If you're not going to be changing your things constantly, you could use a longer time to live. Here's the thing, longer time to live, more scalable, shorter time to live, more flexible and agile. So the business will determine what it needs to be. Now, your TTL or time to live is usually measured in seconds unless confirmed otherwise. And there's going to be a massive list of types of DNS records. We're going to talk about some of the most common ones that you need to know very soon. Now, when we're dealing with AWS, we've got a really cool system called Route 53, which is a highly scalable, low latency platform. It uses health checks. It's high availability to a point. Here's the problem. In a multi-cloud environment, if we're using AWS DNS, and we have an Azure cloud and an OpenStack cloud, and the AWS DNS cloud goes down, guess what we don't have? Any of our clouds working. So when it really matters, you're probably not going to be using AWS Route 53. You're going to be going to like a company called F5, and you're going to be putting DNS servers in all your clouds, and you won't be using this management system. Is AWS Route 53 a great DNS service? It's a great DNS service, but 1 is none, 2 is 1, and 3 is greater than 2. So if it really matters, you're going to not be using AWS Route 53. You're going to be using a better, more robust DNS solution. Now, here's the thing. For the most part, everything we say from now on will work on anybody's DNS servers anywhere, and every cloud, because it doesn't matter. So you can see we've got a lot of DNS records, an A record, an AAA record, a CNAME record, a certificate authority record, an MX record, an SPF Center Policy Framework record, and we can talk about what some of these records are. A text record. We're going to go through the ones that you need to know, and you do need to know some of them. I'm going to begin with an A record. Woohoo, this is simple. Maps a name to an IP address. Go cloud careers to a single name. Very simple. Most fundamental. Next, you've got something called an A record. So an A record maps a name to an IP address. Simple, 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 simple. Simple. Next, A record. It's the same as an A record, but for IPv6. Simple, simple, simple. What is a CNAME record? Okay. Let's talk about a CNAME record. I decided I was going to create Go Cloud Architects about 1.5 years ago because I was upset by the training that existed out there. Getting architects hired day in, day out, day in, day out. Architects are getting hired every day. And then somebody says, Mike, could you do some soft skill training for our company? And I say, sure. And then out of nowhere, someone says, Mike, I want to be a cloud engineer. And I say, you know what? We need a cloud engineering program. So now we can't just be Go Cloud Architects, we're Go Cloud Careers. Because we train leadership skills, we train cloud engineers and cloud architects, all about optimizing people's careers. So now I've got a new website, www.gocloudcareers.com. But I still have people trying to go to www.gocloudarchitects.com. So I created a CNAME record which mapped domain A to domain B. And now anybody that goes to www.gocloudarchitects.com gets sent to www.gocloudcareers.com anyway. They don't even know it. It's hidden. So that's a CNAME record. It's kind of like an alias record. Map domain A to domain B. So A record or AA record, simple mapping of a name and an IP address. CNAME record. Remember I showed you that ugly CloudFront distribution name, but Amazon.com was cool. So we can map Amazon to that ugly CNAME record and everybody's happy. Mapping a domain to a domain. Next, NS record. It's a name server record, and it identifies the DNS servers that are responsible for your DNS zone. And you can have more than one. These are the authoritative name servers that propagate your official DNS information across the internet. How about an MX record, by the way? Well, an MX record specifies which mail servers can accept mail for your domain. Would you like to receive email? Then you need an MX record. So the next kind of record we'll talk about is an SOA, or Start of Authority record. This identifies the primary name server for the domain, the responsible party for the domain, and a timestamp that changes whenever you update your domain. This number is measured in the number of seconds before the zone should be refreshed. Amazon Route 53 is the AWS high availability DNS system. It's designed to give AWS clients low-cost DNS routing services It works with IPv4 or IPv6. You can use it because it's just a DNS service in and out of your customer's network. But again, remember, if it fails, you lose everything. So you might want to use something more. Route 53 uses something called health checks, and I love health checks, and I got a way to explain health checks so you will understand it and never forget it again. And you can also use AWS Route 53 to register your domain names, etc. So AWS, look, it's a good DNS service. Don't take me wrong. It's a very good DNS service. I just don't use proprietary anything, and I don't use single points of failures because customers don't come to me and say, Mike, could you design systems for my grocery store? They say, Mike, how do I design my my trillion-dollar bank? Or Mike, how do I make my hospital work so that if the systems go down, nobody dies? So I don't get to deal with these kind of things. I have to deal with big world, real world environments. But it's a great service. And many organizations can get away with this. Many. It's based upon the business requirements you're dealing with. Now, we're going to deal with a lot of routing. And guess what? The same routing works on all clouds and all providers and all DNS servers. We're going to be talking about simple routing, weighted routing, latency-based routing, failover routing, geolocation routing, multi-value answer routing, and geo-proximity routing. So let's talk about simple routing. Maps and name to an IP address. Very simple and elegant. Here's your username, and it maps it to a single IP address. Done. Simple routing. Let's talk about weighted routing. Now, architects don't touch DevOps, ever. And if we had Git projects on our resume, it looks pretty bad. But we do occasionally talk to the DevOps engineers, and they say, hey, Mike, I got a new website that's going on, or our software developers, and I'd like to test it. Is there a way that we can send 10% of your traffic to this website, the new website that we can test it, while still keeping 90% of the traffic on the website that works? And the executives of the company say, yes, I'd like to do this. So we use what's called rated routing as architects. And we say, sure, DevOps engineer, application architect, I got you covered. We will speak with the executives. We will tell them we want to use a weighted routing policy. And then the engineers implement it. And what we can do is send 10% to one and 90% to another. Think of a blue-green deployment. Or let's look at it this way. You've got your data center. It's up and operational. And you want to send 50% to data center one and 50% to the cloud provider. Weighted routing. Or send 33% to my Kubernetes cloud, 33% to my Azure cloud, and 30% to the AWS cloud. And if the AWS cloud dies or the Azure cloud dies, send the rest of the traffic to everybody else. That's called weighted routing. So weighted routing is brilliant. It enables you to do new software testing. It enables you to load share across data centers, etc. Use it all the time. Latency-based routing.
Hey, Mike, I think there's something that we, it's a couple of people have brought it up. Okay. It was something that you were going over about 4 or 5 minutes ago.
Okay.
I don't know what it means. It's just something that you were doing maybe on screen. That
okay,
there was a delay or latency and it didn't come. It wasn't clear.
Okay, so when you're dealing with DNS, you've got a fully qualified domain name, which includes a host name, a domain name, and then a top-level domain. A top-level domain can be .uk, .co, .com, .net, etc. Now, the host name could be something like mikesmac.gocloudcareers.com. The host name would be Mike's Mac. Then it would attach to the domain name GoCloudCareers, and then the suffix or the domain suffix would be, or the top of the domain would be .com, for example. That's what's called the fully qualified domain name. Now, it could also be www. It could also be considered as the host name, where GoCloudCareers would be considered the domain name, and the top level domain would be .net. Oh, perfect, Ellen, you got it. I'm so happy. Wonderful, Ellen.
Sorry, even Abigail mentioned that she missed it. So
I'm thrilled to go over anything. That's why I'm so appreciative that the team is there looking at things, because I can't monitor comments, etc.
Yeah, normally I don't chop in unless
Please do so. Please keep doing it. I want to make this the best training that anybody could get. even if they paid for it thousands of dollars, and I want to make it free. So please help me make it better. So let's talk latency-based routing. What's user experience related to latency? If I want to go to www.gocloudcareers.com and it takes a long time for me to feel it, it comes back to me, I'm not going to be happy with the website. But if it comes back to me instantly, it's pretty there. So let's say you've got multiple data centers. Everybody's got multiple data centers. And I'm sitting here in Palm Beach, Florida. Data center 1 is New York City. Data center 2 is San Francisco. When I make my web request to www.gocloudcareers.com, it might be faster to get to New York, or it might be faster to get to San Francisco, but we don't know what's going on in the network, the servers, the network utilization, etc. What latency-based routing is, I make that web request, the DNS server sends it, and they say, Mike, fastest server for you is in San Francisco, we're going to send you there. That's latency-based routing. So this is really, really there. Really there. And that's why we're using these things easily. That's why we're using them. That's what's going on with latency-based routing. Let's say you're in Greece and you got a choice of 2 websites. Then where's the web servers in London, which isn't too far away. You also got a web server in Constantinople or Istanbul, not too far away, right? What's the fastest website for you to get to? That's latency-based routing. Let's talk about failover routing. I love failover routing. Let's say you've got systems in your AWS cloud, and you got your Azure cloud running in a failover situation. Send all data from AWS. AWS crashes. Cloud goes down, it happens all the time, not all the time, but periodically. Send all your data to Azure. High availability, everybody. Good systems working. Geolocation routing. This is pretty awesome. Geolocation routing policies route your user to the website that is closest based upon what they need. So picture this. I'm in North America, I get sent to a North American server. I'm in South America, I get sent to a South American server, but it gets better than this. Let's say we're in Nigeria for right now. There's a lot of languages spoken in Nigeria, but let's say we're concerned about English and Arabic. With geolocation router, I can say, this person's in the English section, send them to the English website. They're in this section of Nigeria, send them to the Arabic website. That's pretty powerful stuff. So we're dealing with this as following. Geolocation can send you to the website in the language of your choice based upon your geography. Have somebody in Japan, send them to a Japanese website. Have somebody in Hong Kong, send them to a Chinese website. Wow, how cool is that? That's geolocation routing. I love it. It looks at your IP address, determines your source, and sends it to the equivalent. Multi-value answer. This, in my mind, is just silly. It's like rolling the dice. Here, this time you're going to go to this server. Here, you're going to go to this server, roll the dice, flip a coin. Here, you're going to go to this server. I don't do anything, and I don't know where it's coming from. Last one we'll talk about is geo-proximity routing. What happens is AWS will basically give you geographic regions, and they look like this. And I took this picture from AWS, and you can see we cited it accordingly. What you can do is you can create something called a bias, where you can make the yellow region bigger or smaller, and therefore determine how your traffic can go. And that's geo-proximity routing. Now, how does DNS work to improve availability of your systems, assuming your DNS services don't go down? And how does this work? We use something called the health check. I love health checks. Load balancers use health checks. Routers use hellos, which are basically health checks. What does a health check do? Well, here's the way it works. Let's say you got 2 servers. And there's your DNS. Server 1, are you there? Hi, I'm here, server 1. Server 2, are you there? Yes, I'm here. Server 1, are you there? I'm here, I'm all good. Server 2, are you there? No response. Ooh, not good. Server 1, are you there? Yes, I'm here. Happy to work. Present and accounted for. Server 2, are you there? No response. Server 1, are you there? Yes, I'm here. It's party time. I'm serving up web pages. Life's good. Server 2, are you there? No response. DNS sends all new traffic to server 1 that's there. That's what a health check does. So make sure you don't send traffic to a bad or a down web server. Let's talk about load balancers. Now, we network architects don't work with load balancers because we do routing and switching. Some networking engineers actually touch this stuff. And I love load balancers. I think they are the coolest devices in the entire world. Why do I like load balancers? Well, they improve availability and performance. Wow, better availability and performance in a single device? I need that device. And I bought a lot of load balancers from F5 or recommended a lot of load balancers over the years from F5 for this reason. Improve speed and availability in a single device. How many of these can we buy and put them out? It's the best device in the world other than your routers. So a load balancer is a device that's going to distribute traffic. It's going to help organizations scale by removing the limitations of single servers, single points of failure, and the performance limitation of any server. You know, once you start getting to these servers with 192 cores and 8 terabytes of RAM, you may need 1,000 of them for an application for a critical business. That might be what it takes. And so you need the load balancers to load it up. Now, load balancers spread the load across multiple servers. How does that work? Server 1, are you there? Yep. Server 2, are you there? Yep. Server 3, are you there? Yep. And it sends the load to all servers. Now, just like DNS, these things run a health check. Server 1, are you there? Woohoo, I'm here. Server 2, are you there? Woohoo, I'm here. Server 3, are you there? No response. Server 1, are you there? Yeah, I'm here, ready to party. Server 2, working hard. Server 3, are you there? No. Okay, we're going to run one health check because typically these things take 3. Server 1, are there? Yeah, serving up website, having parties here. Let's have a celebration at the end of the day. Server 2, you having fun? Yeah, working hard. Server 3, are you there? Server 1 and server 2, you're getting all the traffic now. Server 3 is dead. That's how load balancers improve availability. How do they improve performance? Server 1 work, server 2 work, server 3 work, server 1 work, server 2 work, server 3 work. Wow. Is that like RAID? Yeah. Is that like link aggregation groups where we bundle the full 10 gig links in together to be a 40 link group? Yeah. Same thing. The tech never changes. It's just how we use it that changes. Which is why when your fundamentals are strong and you know the network in the data center, you know the cloud. If you just learn the cloud, you don't know the network in the data center, you don't know what to do. So load balancers operate at 2 layers, layer 4 and layer 7. I'm a networking guy. I use network load balancers. But there are times where we need application intelligence, in which case we use layer 7 balancers, which is an application load balancer. So when do you use which? Well, sometimes you actually need to use both at the same time. Yes, you heard me, both at the same time. We need speed and intelligence. But remember this. Load balancers are there for performance. Now, we're dealing with 2 things. We're dealing with AWS. How do you know what it is? You smack the word elastic on it, and you give it a branding name. But this name isn't too funny. Elastic load balancer, network load balancer. Okay, elastic load balancer, application load balancer. Now you know what the 2 options are. But when do you use what and when and how? Well, actually, let's talk a little bit more about, so when do you use, wait, I'm going to tell you right now. For network devices, we send to the network. These network load balancers. I need big, powerful servers. I use network load balancers. Hugely powerful network load balancers. Why? I need speed. Here's what a network load balancer looks like. Source address, destination address, TCP, UDP, port number, protocol. That's it. So, all of you with me, do some math. You're going to be a network load balancer. 2 and 2 and 2 is 4 and 2 is 6 and 2 is 8 and 2 is 10 and 2 is 12 and 2 is 14 and 2 is 16, 2 is 18, 2 is 20, 2 is 20, 22. Pretty easy, right? Network load balancer, looking at nothing. Now, all of you calculate a derivative in your head. Huh? What? Calculus derivative? Okay. Do derivative 1. A month later, when you're done that, do derivative 2. Okay, you get the concept. Network load balancers do something that's very simple, And that's why they're fast, fast, fast. Application load balancers do something very intelligent, and that's why they're slow, slow, slow. What do you use? What does the application need? What does the business requirements need? That's how you determine what to use. Now, sometimes you need to use them both together. And if we have time, I'll architect that with you and show you. It's way out of the AWS Certified Solution Architect Professional course, but it is reality in real life architecture. So if there's time, maybe we'll do some extra bonus stuff. So let's talk about when using load balancers, and we'll use some AWS terms for the engineers that are going to be here. The load balancers distribute traffic to your systems, virtual machines, firewalls, whatever. Those systems that you send data to are called targets in the AWS world. AWS load balancers are auto-scaling, meaning they give you the performance you need, etc., etc. Load balancers can balance across availability zones. They do health checks, like I told you, and showed you how that works. And they also support, they can terminate SSL connections. Okay, so HTTPS connection coming in, HTTPS connection coming in, HTTPS connection coming in. Guess what? You're good. It terminates the SSL on the load balancer, which means you don't actually have to deal with it on the servers, further offloading your servers. I'm going to make this very clear because it keeps popping up. I see it across the screen. Architects design, present, and sell. SysOps people are the maintenance people. And DevOps people automate software release cycles. It's 3 different careers. Pick the career you want and learn that, but don't learn everybody else's career. Let me go back to this. Doesn't benefit you to learn other people's jobs. So network load balancers are so fast, they literally can handle millions of requests per second. And they're stateful too. It's pretty cool. It creates a flow. Information goes in the load balancer, out the load balancer. And it can student it. It's because it's a flow. It's called sticky. Boom, comes into this server, goes to this server, goes to this server. And it's all kinds of excellent and all kinds of perfect. So kind of keep that in the back of your mind. That's your network load balancer. Now we can put a static IP address on the load balancer. How could you not? But you can definitely do it. And we can route to containers with the network load balancers or application load balancers. But generally speaking, routing to containers, you're going to use an application load balancer. What does it look like? I'll give you a picture. Here we've got a network load balancer, and we're load balancing, in this case, across availability zones, and we're load balancing across servers. And it's just no big deal. We're load balancing across availability zones. Now let's talk about an application load balancer. This is a little different. It operates at layer 7 of the Osi Model. Remember that application layer we just talked about? In this particular case, what we're dealing is the application load balancer will look at the path provided in the URL. So we're getting deep. Elements in the HTTP or HTTPS header, whether we're using an HTTP method such as push or get. So this is really good for load balancing HTTP traffic, container-based applications, microservices, etc. Now this is slower because it's operating at a different layer. Now here you got a load balancer, that application load balancer. It's sending it to targets or target groups, and it's realistically speaking looking at detailed information. Now I'm going to bring it up just in case you see it on your exams. AWS has something called the classic load balancer. And here's the thing. Network and application and how they work identical to all these load balancers, but AWS didn't want to use it anymore. They created a new one with their new branding, Elastic Everything, Elastic Load Balancer. So classic load balancers, which are being deprecated, provide the same functionality, and they can work with your old EC2 Classic, VPC, pastings, whatever else. They auto-scale, they did things in the exact same manner. Now let's talk about internal load balancers versus external load balancers. Let's think about this. When you need a load balancer for the internet, it's an external load balancer. And the edge of the load balancer gets a public IP address. But what if you need the load balancer for your intranet or your organization? Maybe you've got 100 HR servers. Do you want those HR servers exposed to the internet? No. But you still need to load share across servers. That would be an internal load balancer. External load balancers are often called internet-facing load balancers. Let's talk about some test questions that you could get most likely in the Certified Solutions Architect Professional, but it could potentially pop up on the Certified Solution Architect Associate. You never know what's going to pop up there. So we give you 10 times more than you need, and that way we know you should be good to go. Although you're willing to practice test to get used to the way these people answer things. So let's talk about listeners. Here's what ultimately happens. The load balancer listens for stuff coming in. That's a listener. I'm waiting for my TCP, my UDP, my TCP UDP, et cetera, for a network load balancer. Application load balancers are looking for HTTP, HTTP request, et cetera, So listeners coming in. Targets, where do we send your traffic? Do we send it to a server? Do we send it to a firewall? Do we send it to an IDS, IPS system? That's your target. Now, the target can be set to an instance for the engineers that are going to configure this, or an IP address for the people that are going to configure this. But if your target is an IP address, the IP addresses must come out of the following spaces, either from RFC 1918 or from RFC 6598. As you probably know, the RFC 19 private address space is the 10.0.0/8, the 172.16.0.0/12, and the 192.168.0.0/16. That's specified from RFC 1918. Now, when you're dealing with the RFC 6598, what you're dealing with is something called a shared address space. And that's the 100.64.0.0/10. That's your shared address space. Let's talk about, target groups. You know how in IAM or identity access management or something like this, you've got the ability to group accounting users and to give them all specific permissions. Well, with load balancers, what we've got the option to do is to do target groups. What are target groups? It enables you to just route to a group of servers or systems, and they call it a target group. Group of virtual machines. Let's talk about sticky sessions. By default, not a network load balancer because they're sticky by default. But by default, an application load balancer will route each request to the server with the lowest load. Makes sense. But what if you want Mike's traffic to go to server 1, Ivadike's traffic to go to server 2, Chow's traffic to go to 3, Lara's traffic to go to server 4, Dylan's traffic to say on server 5. We can do that. Praveen's traffic on server 6. We can easily do this. Easily. But a network load balancer, it's by default. On the application load balancer, we have to create a sticky session. What has to happen is a cookie is given, and the cookie will be used to tell the system where to send the request. It can still be done in application load balancer. And I explained to you in pretty good depth what is a health check. Now, the next up is going to be security. I may be able to start the security today, or we can stop it here, but let's see if there's any questions. NS lookups translate a DNS address to an IP address. Exactly. Dylan, would NS records allow you to use F5 and Route 53 in parallel? It's going to get you in trouble. So if you need high availability systems that are going to be greater than a single cloud provider, you're just going to use F5 devices in all 3 or 4 clouds and data centers you use. So is failover router equivalent to high availability routes? Not even close. High availability routers, Will I am, is the following. You can have a router that's not high availability. It's a $3,000 router. You plug it into the internet. You plug it into your, what do you call it? You plug it into your power and life's good. Now, I want you to think about this. If your power supply, you get a power failure, goes down, or your circuit breaker blows, you're done. Now let's turn that router into a high availability router. Now we're going to have a router and it's going to have 2 power supplies. And and data centers don't have power failure for this reason, because they think about it. Now on the high availability router, we're going to have cord 1 plugged into one circuit on one circuit breaker, cord 2 plugged into a circuit on another circuit breaker. Now what else are we going to do in this high availability router? A router has a brain, it's called the control module. But imagine one of the brains gets drunk or gets a headache or doesn't work. Well, do we want the router to fail? No. So we're going to put 2 brains in there, or 2 control modules. So control module 1 fails, we're still good, control module. So now we can have a power failure or circuit breaker in one outlet and lose the brain of the router and still be good. Now, now let's say we're connecting the routers to the cloud, and we have 4 links in the link aggregation group. Routers have what's called line cards. Now we can put all 4 links in the same line card. And if that line card crashes or fails, guess what? We lose all 4 links. Or in the high availability router, we can put 2 control modules, 2 brains, 2 power supplies that are attached to different circuits, and 4 control modules, and plug 1 part into each 4 line cards. So now we can lose 3 of the 4 line cards, 3 of the 4 connections, and then still reach the cloud. 2 sets of power supplies, so we can lose a circuit or a circuit breaker, and we can lose the main brain to the cloud. That is high availability routers. Failover routing is just a DNS policy that says, hey, go to the data center. If it's not using the data center, go to the AWS cloud. That's all. That's the difference. They're very different. But great question, Bill. Excellent question. Okay, so, while we're at it, let's kind of talk about high availability in general. With high availability, you saw what we put in one router. We probably still need 2 of those routers. Now with high availability, our connections to the cloud, if the 4 connections on router 1 or on, say, Verizon, what about router 2 connecting to the cloud provider? Can they be on Verizon? No, because if Verizon has a network outage, guess what? We're all down. So the next one will be on, say, a different service provider like AT&T or NTT or CenturyLink. So all network architects for the last 30 years, including the internet service providers, will tell you we're not fully redundant, so use multiple routers and multiple service providers. Now, why don't data centers have power failures except for the AWS data centers? The first one I've ever seen that had a power failure in 25 years. They are high availability systems. And we'll get back to the questions in a minute. I just want to cover the availability. So we have 2 power companies coming into most data centers with multiple, guess what? Transformers bringing the power, because if a transformer gets hit by lightning, we can't have the data center go down. So this is why AWS is the only data center I've ever seen have a power failure in 25 years that was major. Now, next, 2 power companies coming in. Is that high availability? Of course it's not. We need generators. Do we use 1 generator? Of course not. We use multiple generators. Now, sometimes we put backup generators in there. If it matters, look for an internet service provider. And then sometimes we have UPSs or battery backup backing that up. So we can have 4 levels of power failure in some data centers, which is what it takes for high availability, which is why until AWS's power outage, any of the architects I've never seen knew never saw one in their entire lives. Unless something else happens and we don't know what it is. Chow, can you bring in the next question? Is the cloud architect a prerequisite if your goal is sysops admin? Charles, absolutely not. Sysadmin is where people start their careers. And they usually come to me because they don't want to be a sysadmin anymore. So you can start your goal as a sysadmin. Basically, if you want to be a sysops admin, know Linux like the back of your hand, get extremely good Linux skills, get some scripting skills that are really good, such as bash shell scripting in Linux and maybe some Python scripting. If your goal is sysops, get used to those management systems that can be used and all the logging functionality. Get used to writing a Linux script to parse a log, grep for this pipe, and send it to something else. So no, the sysadmin is where people start their careers if people, and the sysadmin people, the people that, you don't have to start your career there. I have people starting my careers as cloud engineers and cloud architects, but a cloud architect in terms of salary is at the top. And you don't go from a cloud architect to then go to the introductory maintenance person on the cloud, unless you wanted to. So if your goal is sysops, that's an intro level job. And, those are the things that you're going to be good at. And administering things and configuring things in the cloud. So you don't become a designer, presenter, seller, executive only to do this. And no, it's the exact opposite way to go. If your goal is to be sysops, do sysops. Again, train for your job and not somebody else's. Charlie can bring in the next one. Brian, what was the name of the routing session? I called that the random one. Let me actually look that up real quick. And the reason I say look that up is it's something I want. Hold on. Multi-value. Multi-value answer. Yeah, it's multi-value answer. It's something I would never use. Roll the dice. Multi-value answer for that one. Chris or Chal, one of you can go to the next one. Effie. It appears DNS Route 53 can act like a load balancer which operates in failover mode, right? Not at all, although it does similar things. In other words, they provide more services. Not at all. Load balancers do load balancing and DNS does. So load balancers are fast, high-performance devices that improve performance and availability by sharing the load off of servers or sharing the load between routers. DNS is much lower performance than it says. Send your traffic to data center 1 or data center 2. It's not exactly load balancing. It can act in a way similar, but you couldn't use it as a load balancer because the performance would be bad and your systems wouldn't work. But it's a great question there. And a lot of people confuse that. Are cloud load balancers the same as an elastic load balancers? Effectively, yes, but AWS doesn't want you to use them. Thank you so much. I'm grateful I have found Mike. He clarifies the topics and concepts. There is plenty of miscommunication and misunderstanding, and it does not help people. Ipv6, thank you so much. I know we have had the pleasure of working with you. And for those that are here, I've recently worked with Ipv6 on 13 blogs to help you with your interviewing things. And they're going to be released constantly. So please follow me on LinkedIn and follow Ipv6 on LinkedIn. But that's neither here nor there. It's been an honor to work with you. And there is so many misconceptions. That's why I came out of retirement. I don't need to work. I was retired. I came out of retirement because I saw the courses that were out there and the advice of here, learn sysops and DevOps to be an architect. Or here, take these 10 certifications in other people's careers. Effie, are elastic load balancers compatible with GCP? Well, we wouldn't be using elastic load balancers in GCP. We'd be using what they call cloud load balancers. But yes, the good news is we can use these load balancers per cloud and not have a problem. Preserve source IP in case of NLB. NLBs are naturally sticky, not because of preserving any IP addresses at all, but because the way they look at a flow. TCP source address, destination address, TCP port protocol, and port number. That's it. So that's why they're sticky. If we use production and disaster recovery on multi-cloud or different cloud, how do we switch from production or one cloud to another cloud in case of disaster recovery? Well, you guess. You got DNS servers in multiple clouds talking to each other with health checks. Now you got, and there's 4 ways we could do this disaster recovery based upon what's needed. But the reality is let's say you've got an AWS data center and an Azure data center. Now, granted, we're not going to use Azure DNS, and we're not going to use AWS Route 53. In each data center, we're going to say F5, and we're going to have data centers that talk to each other. Data center 1 server, there, yep, good. Data center 2, we're there. And then what's going to happen is as follows. These data centers are going to talk to these DNS servers are going to talk to bigger servers in the internet. They're also going to do health checks. Now, here we go. Life's really good. We're sending data completely to AWS. Our DNS servers detect that AWS is down. Do the health checks, which I went through with you. And then the cloud then sends the data to the next cloud. And while that goes, DNS health checks are going to be up and up and up. The primary cloud goes up. DNS health check will go back there. And when everything thinks it's good, it will reroute the traffic to one or both or what have you. That's how it works. Good questions. Can I explain how internet DNS servers are highly available? Yeah, you use a lot of them. It's simply 1 is none, 2 is 1, and 3 is greater than 2. You use a lot of them. They also use something called Anycast, which is probably a little bit beyond this, kind of beyond the Certified Solution Architect Professional. But actually, while we're at it, I'll show you what. I'll make it clear for you. I want you guys to get a real education. I really do. So let me show you some Anycast. So here's what Anycast is. You've got DNS server over here and a DNS server. Didn't work. DNS server over here. Now Google uses Anycast and their DNS server is at 8.8.8.8. Now over here, we've got the other Google server 8.8.8.8. Now what's going on is something is synchronizing these two devices from higher up. And then where we run into the challenge is going to be as follows. So this is across the entire internet. So let's go across the entire internet and have a little fun over here. So over here on one side of the internet, we're sitting in Florida. And in Florida, we've got my great internet user, Cindy the cat. She's over here and she wants to go to the internet. And on the south side, we've got, I think it's Asheville, North Carolina, where Abigail is, and her beautiful cat, Noni. Look, everybody's cat is great. The reason I love Noni so much is she looks just like Cindy, who's my beautiful little daughter over here. So we've got over here, let's talk about geography, because geography matters as it pertains to latency. Over here right now, we've got let's say North Carolina. And over here, we've got Florida, where Cindy is. Here's what happened. Cindy wants to go to www.gocloudcareers.com because she likes that website, because she's our official troubleshooting coach. She pulls out plugs. She powers off servers with her paws. She chews through Ethernet cables. She's a great troubleshooting coach. And she wants to go to the www.gocloudcareers.com to learn more ways to hack into her daddy's systems. So she goes to the internet, and when she goes to the internet, she hits her local DNS server, that local one that I'm moving around. This is the close one to her. Now, this is great. Now, over here, we've got Noni the cat. Noni the cat is really interested in the world's greatest tuna. So she goes to Google search. Where can I get the finest tuna in the world? Now, Noni, you can see who's over here, goes to her DNS server over here. And how does the internet routing work, even though they have the same address? Well, Noni's closer to this DNS server, so the internet router sends her here. Now, here's how Anycast works. So right now, Noni's going through this 8.8.8 on this side. Cindy's going over here to learn how to hack her daddy's network on this side. And now what happens? This DNS server dies. It happens. So now, guess what? Cindy still wants to research how to kill her daddy's servers because she's a mischievous little thing, though I love her deeply. So now Cindy's request goes to the North Carolina DNS server, the same one that this beautiful Noni the cat is using over here. And that's how it works. That's what Anycast DNS, and this is how high availability DNS servers actually work in real life. Hope I answered your question there, Casil. In reality, Cindy already knows how to kill the servers. Yes, because Cindy is an expert. She has caused me more OpenStack cloud outages with her pawing things off. I have to have a second person proofread my documents because literally speaking, she walks over on my keyword. She has tuned through an Ethernet cable and she has unplugged a lot of my servers. Yes, she's a good troubleshooting coach. She doesn't need to do any more research, but yes, she's probably out there doing research. Chris, we can bring in the next one. And actually, I'm even thinking of making her a LinkedIn page. Because I think there's a couple more questions coming in here, and they seem like they're very good technical questions, so I want to answer them. Oh, okay. Actually, you know what? I'm going to also have Chris share this with you. I'd love you guys to all check it out today. I recently made a magazine article on how to get hired in the down economy. And, you know, I enjoyed being interviewed for this. So I'm going to have my team pop a link to that magazine article because I want to know that you guys can get hired under any circumstances. So please check that out. Follow me on LinkedIn, but also check it out. Hope you like the post. And if you do, like it, comment it, and share it to help others. Maria S. As a CCNA holder, will I have any advantage studying the SAA? I don't know. And here's the thing. I don't know what, I see anybody can pass the CCNA, anybody can pass the CCIE, anybody can pass the CCIE. It's what's in your head that really matters. So if you understand the CCNA material very well, it'll be hugely helpful. But if you did what most people did, which is basically just did some configuration tasks, learned the name of a service and did some configuration, and then used a practice test to pass the exam, then it's no benefit. So it's all that you know the network. So Maria, if you know BGP, yes, you're strategically advantaged. Not how to configure it. None of this router BGP 65312, neighbor 192.168, remote AS 65313, network 10.0.0, mask 255.255.0.0, aggregate address 190, whatever. That is not going to make it easy for you. Now, if you've been doing subnet planning, if you've been designing BGP architectures, if you were designing the VRRP on a layer 2 network, which you could be doing as a CCNA, if you were dealing with OSPF and constraining the IGPs, you know, what needs to be in area 1, 2, 3, or 4, then yes, it'll be hugely beneficial to you. What is the difference between a global accelerator? One's talking about accelerating your traffic, and one's related to load balancing between servers. Okay. Do load balancers ensure your app has the right amount of capacity? Absolutely not. The architect works with the engineers to determine what are the requirements for the application. What do the virtual machines need to look like? How many CPU cores does each virtual machine need to look like? What kind of disk performance does each system need to look like? How much DRAM needs to be in the memory? Do you need GPU in the systems? And then how many of those systems do you use? Now, we can use the load balancer to assist us with auto scaling and capacity, but still, we need to determine what those servers are, how many we need to reserve, what the capacity is. So all this, and here's the magic of architecture. And here's why engineering and architecture is exactly opposite. Engineering is how do I fix this one thing? Architecture is how do we design the end-to-end system? That's why it's so complicated and so different. We determine that when we build the design. Oh, that's really great, Jim. Cindy does make the servers catatonic. Oh, wow. Somebody thought I was funny. I'm so happy for this because nobody sees me as funny. So if I made the Hall of Fame for humor, I'm super happy. Spread the word, tweet it out, tell somebody I got a sense of humor.
Mike, sorry to bust your bubble. They're saying Jim made the Hall of Fame with his catatonic comment.
Oh, well, like
better
I said,
luck. Better
I'm
luck.
not known for my sense of humor. I'm
Better
known for
luck.
getting people hired, promoted, paid a lot more than the competition, designing networks and systems to help businesses, but I've not been known for this. Well, best way I can describe it, Effie, is we had a lot of authors working on that book. So work with what I'm describing you today. What a time to be alive, cats and tech. Yes, clouds to the moon. I totally agree with you. We've got some special cats and special tech. One is the world's greatest thing. So let me just think about something for a minute. I want to see where we are and if we can do something. How's everybody feeling? We all feeling good and strong and happy?
Well, why don't you just ask us what you really want to ask us, Mike?
I got an option over here that I'm debating. I can run about 45 minutes late today and about 45 minutes late tomorrow. And if we do that, we don't need to do Saturday. Or we can do Saturday. So how's everybody feeling?
Let's go with a thumbs up if you want to keep going and don't do Saturday. Give us a thumbs up. If you want to stop and do a Saturday, give us a thumbs down.
Just check the weather outside while we're at it to make sure I don't get murdered from my family that I promised to take to the beach. Okay, it looks like we're going to go for about 30 minutes longer or so, 30 to 45 minutes longer. Just tell some people. Okay, let's keep going. Let's keep going. So everybody, give me a hashtag AWS Certified Solutions Architect Associate 2022. Let's start talking about security. One of my favorite things. And please, everybody, please check out my article on LinkedIn today. I want you to see that article so you know that under any circumstances you do the right things can happen to you. So under the security section, which we're going to do a little today and a little tomorrow, and that way we probably don't have to do Saturday, we're going to do the following. We're going to be covering who is responsible for what, the principle of least privilege. We'll talk a little bit about industry compliance, a little bit, and actually I recommend you don't do the AWS security specialty because it's not even an intro to junior level security. And depending upon what your career is, and you can ask me the question and answer tomorrow, I'll tell you what you should learn. We'll talk about identity and access management. We'll talk about multi-account strategies. We'll talk about a little more about access control of security groups and WAF. We'll touch on intrusion detection prevention, distributed denial of service attacks, the service catalog, and the systems manager parameter store. So let's talk a little bit about this. Who is responsible for what? This area causes more confusion and more cloud hacking than you can imagine. The cloud is hacked on a daily basis. Organization systems are in the hack. Most frequently, attacks occur because people don't understand how to secure their S3 buckets, but they occur from lack of understanding about firewalls, IDS, IPS systems, and what is acceptable security. Think of it this way. AWS manages their infrastructure, their physical servers, their routers, their switches, their physical firewalls, their physical load balancers, their storage. They maintain that. You maintain the security of your stuff, your VPC, otherwise known as your virtual private data center. They call that the shared responsibility model. Oh my God. So we'll make that very clear for you. The customer manages the users and the roles, like their identity and access management. The customer manages patching the operating systems of their virtual machines. The customer deals with their security configuration to lock their systems down as needed. The customer deals with the physical devices. Here, you got a router in your network, your data, your customer on premise. Here's your cloud. Anybody can just plug into your router. Guess what? They're on your cloud, depending upon how you set it up, right or wrong. You know, if you set it up and locked it up and used 802.1x authentication, etc., way beyond the scope of this, or even the AWS Advanced Networking, we're now getting into CCI level stuff. But then, guess what? That's how you lock it down. So let's kind of make it look kind of simple. Here's the stuff they do. Their stuff. The regions, edge locations, availability zones, compute, storage, networking. Here's the stuff that you manage. Your data, your operating systems and networking things inside your virtual data center, your encryption, your identity and access management systems, and you know what kind of network ACL security groups, etc. That's very simple. They manage their stuff, you manage yours. That's it. Done. Very simple. We don't have to use complicated terms like shared responsibility model. There's another term used in security called principle of least privilege. I hate this name. The military has a better acronym. Need to know. If you don't need to know it, you don't get the information. You can't damage anybody that way. Principle of least privilege is just the military's need to know. Do not give someone access to more than they need. And when you know they're no longer working for you, yank their rights. That's why sometimes in poorly run organization, sometimes people find out they're fired or laid off because they try to log into their email and they can't. They call tech support and tech support panics and they're like, huh, you didn't know you were fired. That's the principle of least privilege. It's horrible. I've seen it happen too many times to people, especially at some hospital. People call in, they can't access their systems and they just found out they were fired. Traumatic to a lot of people, horrible. So look in this particular environment. Here's what the principle of least privilege is. I've got an administrator. They need to access everything. They log in, they get it. Now I got a user, tries to access this thing. Not required for job function. Blocked all over. So that's really what we're talking about. Let's talk about industry compliance. Look, every industry has some compliance. America Healthcare, we got HIPAA. You want to deal with the federal government, you got FedRAMP standards. You want to deal with payment cards, you got to deal with PCI DSS standards. Look, there's millions of these standards. AWS supports, just like Azure supports, just like Google supports most of these standards. And you can get a full list for them, and I'll a full list under their compliance programs from Amazon, and it changes constantly, so check every time. Now, next, this is a commonly confused thing. I've watched some of those certification trainings and all it was blah, 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 blah. And when you can't explain something simply, it's because you don't know well enough to explain it. So I'm going to make it real simple. Identity and access management is who are you, what you can do, and then keeping track of what you did. Before we use nonsense, fancy terms like identity and access management, we used to call it AAA. Authentication, who are you? Authorization, this is what you're allowed to do and not allowed to do. Accounting, what did you do? Now, when you're dealing with AWS, they define some of these concepts as they'll the terms users and groups and users and roles. Now, inside of your VPC, you can think of an IAM user as a human. I'm a user. You can think of a role as the equivalent of a service account, in case any of you guys have a sysadmin background. We got one server that needs to talk to each other. That's called the service account. Normally, AWS calls it an IAM role. So user, human. IAM role, server to server. There are some other weird things that we'll talk about. So let's look at what identity and access management is. Here we got, I'm signing in. I am Mike Gibbs. Mike Gibbs signed in. He's the CEO of the business. He can access anything he wants. I try to request something and it says, yep. Next, accounting. What did Mike Gibbs do in the network? Track it. That's it. That's identity and access management in a nutshell. Like I said, if you can't explain it simply enough, you don't know it well enough. So let's talk about IAM users. A person. I am an IAM user and I have the permission to interact with AWS services. IAM users are created by principals with administrative access. IAM users can be created in the Management Console, CLI, Software Development Kit, which means the API. And IAM users are permanent. I create a user for Alonzo Coleman. He's on my systems, and I'll be there until I remove it, which I hope never to ever do. And don't think I'll ever need to or want to, but you get the concept. He's going to have that thing. So why do I need a user? I sign in, I'm a user. I get access to this virtual machine, this object storage, and this NoSQL database. EC2, S3, DynamoDB, if you want to use proprietary brand name terms. Now, here's where I'm going to get into the ugly weeds a little bit. We're going to talk about a couple things. A principal. This is an IAM entity that has the permission to access resources. It's called the principal. I didn't make it up. These are AWS terms, which is why it's complicated. Now, the principal could be a root user. It could be the IAM user, and a role, it could be anything. What's the root user? Well, the root user is the person that created the account. The person that created the account has unrestricted credentials. Don't log in with your root user account because you can totally destroy your entire environment instantly. Now, while we're at it, have any of you ever come from a Linux background or Windows or Linux background? They say don't log in as root. It's the same reason. So for your root account, use really long, complicated, strong passwords. Enable multi-factor access and don't use for programmatic access. What is programmatic access? One system accessing another machine. Don't use your root account for this. Now, I view the root account as either the king or queen or whoever's in charge. That's what put a little crowd on them. This person can do anything. Anything, anything, anything. Let's get into the weeds on some of this identity and access management stuff, and tomorrow will be much more fun. Identity and access management is used, as I said, who can access the systems. And we use the concept in AWS of users and groups. What is a user? Me, I'm a user. What is a group? A group of users. Make it easy. Now, imagine you work for a company that's got 400,000 employees. LM, these are your permissions. Charles Peter, these are your permissions. Dylan Williams, these are your permissions. Tiffany, these are your permissions. Alonzo, these are your permissions. For all 400,000 people. Anybody think that's going to be a good idea? No. But what if I could group my users? And this is what is called an IAM group. All users in the sysop environment, you need this access and you get it. Everybody in the finance department needs access to this, and this is what you get. My architects need access to read of this, but they don't need to take your finger or anything, so they don't get that much. My business people makes it very clear. You get access to these. What is a principal? It is a user. That's it. It's just a user. I didn't make up the AWS term, but it's just a user. There's permissions to access the system. So the way groups work are you create a group. Group, accounting. Then you give the permissions to the group, and then you add the users to the group. I add Chow and Hillary to the group of accounting users. Done. And then they inherit the same security policy. Okay, so if I mentioned to you that an IAM user is generally a person, and an IAM role, at least especially at the AWS Certified Solution Architect Associate, is nothing more than a system. When we get into more complicated things with cross-account roles, then things that kind of cross a little bit. But roles are for a system to access a system. Now, there's three kinds of roles. A service role, service account. System 1 accesses System 2. Cross account, you log into Mike Gibbs, GoCloud Careers, and I'm doing VPC Peering with Chow Pham's business, and she's got a business of 1,000 nail salons throughout the world, and we connect to each other. It's a cross account role. Alex, if you focus on application development, you're not a cloud architect. You're an application architect, and you can never work as a cloud architect. So no, you can't be a cloud architect without networking. So let's talk about how roles enhance security. When we're dealing with roles, we're going to be dealing with something very different. If I use a password for the role, and this server gets compromised and the password is lost, does that sound like a good idea? No. But what we can do, this server wants to access this one, use a one-time password, access the system. Server gets compromised, they don't lose anything. Nobody else is going to get it because we're using a password or a token system. So tokens or one-time passwords exchange frequently. So here's the key today. Here's the key an hour from now. Here's the password an hour from now. Here's the password an hour from now. And it's constantly changing. So if the hacker gets access to it, they only get it for a short period of time before it changes, and then they're done. So roles are when systems access other systems. They can be assumed by other services. Roles use short-term credentials, and they typically speaking leverage the AWS Security Token Service, which gives tokens or one-time passwords. So IAM roles are typically used to grant permissions for systems to access other systems, or one account to another account. Again, that's a cross-account role. Now, how does the AWS Security Token Service work? Well, let's talk a little bit first about the credentials. It's a temporary password, and the credential can be as short as 15 minutes or 36 hours, depending upon how you set it up. Once expired, these credentials are no longer valid, and that's what I'm talking about. It makes things much better. Let's talk about a cross-account role. Okay, Chow's got 1,000 nail salons and spas across the country. Over here, I've got a career training program for technology professionals. Why do we need to talk to each other? Probably no reason whatsoever. We decide we're going to talk to each other. And I want Chow to access my systems. And she wants me to look at her systems to see what we can do. Guess what? Use a cross-account role. That's it. Let's talk about some best practices for cross-account role. If I connect my organization to Chow's organization, we can talk to each other. What's the problem? We can talk to each other. So we need to be extra careful. How much do I trust Chow? How much does she trust me? We trust each other a lot, so I'd probably give her unrestricted access because we trust each other. But that's the key. We set it up based upon how we know each other. So cross-account roles enable access to another AWS account. They're often set up as one user account, but it's really about accessing. So what has to happen to set up a cross-account role? You need to do the following: an external ID to uniquely associate the role. And this external ID can basically be a secret identifier that's only known by you and the third party. And you're going to have to specify this ID when you define the trust policy for each one. Third party must provide this ID when they assume the role. I don't want to cover this too much because all this is certified solution architect professional stuff. I don't want to cover it just briefly anyway. So you've got multiple companies that want access to VPC. Each one has to go through determine who there are, what their user credentials are, et cetera, et cetera. That's all it is. So let's talk about service roles. Service roles are application server, talk to the web server, service role. Application server, talk to the database server, service role. And this enables the applications to kind of talk to each other. This enables systems to post into a queue. It enables your virtual machine to access an S3 bucket because it's service roles, it's outside of the system. pretty much. You want to access it. You want to take your EC2 instance and access this Amazon DynamoDB. Your EC2 instance here is an application server. DynamoDB is the NoSQL database server you're using. That's when you use a service role. Now let's talk about things that really scale. The reality is we're not going to be using AWS IAM the way they teach it to you in these courses. Not. Because it's not going to scale. Are we going to have users log into a website? Click this, how to use it, how to use it. No, we're not going to do this. We're going to need some kind of real domain authentication for all of our systems. Who accesses our email? Who accesses this share? Who accesses this? So think about that. Who can access what? So is there any application that 99% of enterprises use for this? Yes, Microsoft Active Directory. What about, have you ever logged in and signed in and it says, log in with Facebook, log in with your Google ID, log in with your LinkedIn ID or your Apple ID? That's also another way we can use authentication. So when we talk about identity federations, what we're talking about is working with and integrating your IAM systems from any cloud provider into the real authentication systems that you're going to use in reality, like Microsoft Active Directory. So by doing this, we create an identity federation, which is basically we trust an external entity and share information. That's all it is. So identity federations enable the management of access identities in a single place, like Microsoft AD. And realistically speaking, the components of an identity federation are an identity, a user, an identity store, the place where the identities are stored, just like Microsoft AD, and an identity broker. Somebody that's going to be the intermediary party between what you're dealing with is, for example, the Active Directory servers and your AWS cloud. So that kind of gives you an idea how that works. Let's talk a little bit about single sign-on. Single sign-on is an authentication method that enables users to securely authenticate with multiple things. So let's think about it this. I'm sure you've all worked at a company or called somebody on the phone. You call somebody on the phone for tech support. You talk to one person. They ask you a bunch of questions. They transfer your call to another person that asks you the same questions all over again. You go to the next one and they ask you the same questions all over, then you get a headache. And then there's the systems that I designed. I designed a system for a bank many years ago. When I'd call the bank, it was an investment bank, and I'd say, it's Mike Gibbs, my stockbroker, whereas the secretary would answer the phone. Hi, Mike, how are you? How's your new house that you just purchased? I see that the holdings that you have done well, although this stock is doing bad. What would you like to do about it? Why? Because I called them. They used the information of my phone call. They got a screen pop on their screen through a computer telephony integration. And then when they transferred the call, they sent my screen pop, all my information about me, and all the information to call. Now the next person picks up and they say, hi, Mr. Gibbs, it's so good to speak to you today. I heard from your advisor that you wanted to do this. Let me help you with this. Seriously, isn't that better? Well, that's all single sign-on is. I sign on once, and we pass my identity credentials across the system, and I now have access to everything I need to. Sign on once. Why is this so good? Well, I'm going to give you a secret about security. If you make it too complicated for the users, they will hack your security. You tell me you need 128 character passwords, and the system, your user has to log into 10 systems. Here's what you're going to see. Sticky notes on their desktop of each password. Now, everybody walking past is going to know their password because they can't remember them. So make one good, strong password. Poof. Use multi-factor authentication for the user. They enter their password. They enter a one-time password. Now they can access everything they're allowed to. That's what single sign-on is about. Here's what we're dealing with. We connect our Active Directory server. The user signs on once, and they access everything. Simple, elegant, and effective. That's your identity federations. So when you're dealing this, there's this AWS service called Amazon Cognito. And that's a service that provides authentication, authorization, and user management for web and mobile applications. It provides a means to connect to identity providers, and Cognito also enables organizations to synchronize their identity management across their mobile devices, etc., like mobile phones. Cognito allows users to sign in directly with a username or password, or with a third-party provider such as Google, Facebook, etc. Basically, what happens, the user authenticates against Cognito and gets a token, and the token is used to provide access. What's that going to look like? Let me show you over here. User comes in, authenticates, gets a token, and accesses their systems. Let's talk a little bit more about Cognito. I'm going to get a little geeky over here. Oops, didn't mean to do that. So Cognito uses the concepts of user pools and identity pools. What is a user pool? It's basically a security directory and a Cognito that's going to enable you and your managed users to be stored in one place. And upon successful authentication, Cognito will issue a temporary set of tokens. It's going to be like a JSON web token. A little more about Amazon Cognito pools. Amazon Cognito identity pools provide temporary credentials, and Cognito identity pools work with but unauthenticated and unauthenticated identities, and Cognito can work with guest and unauthenticated tokens. So now I'm going to get real geeky for you. Here's how the Cognito's pool works. User logs into the identity provider. After authentication, the identity provider provides a session key. Then what happens is the session key is used to issue like an API call or an application call to the Amazon Cognito get ID API. What'll happen then is Cognito is going to validate the session key from the login provider. And if the session key is good, it's going to get a get ID API return with the information it needs to. And then the user is going to send that unique identity to Cognito. Cognito will then validate the session key against the identity provider. And if the key is valid, Cognito will call the secure token service to provide a token, and Cognito will give the temporary service to the user. So that's kind of pretty much how it works. Probably do 5 more minutes and then answer about 5 minutes of questioning, and then we'll do tomorrow and have lots of fun. Let's talk a little bit about the AWS directory service. If you wanted somebody else to manage your stuff for you and manage this, if you manage it yourself, you get the best performance. If somebody else manages for you, get whatever the cookie cutter design is, but it's simple. If you're going to use multiple clouds, which you will be, this is not working. Manage your own Active Directory service, but just know that AWS has a directory service where they provide you hosted, dedicated Windows Active Directory service. Now, they're high availability systems spread across 2 availability zones in case, and that's good in case the cloud crashes. And this enables people that need Microsoft-dependent workloads, for example, to use the Microsoft Active Directory services. These hosted servers can also be secured basically by EC2, your SQL services, and your computing. That's your directory server. Basically, it's using Microsoft Active Directory in the cloud. Of course, you could set up your own Active Directory servers, or you could let them manage it for you. That's what this is. Let me see where we're at over here. Let's talk about authentication options. How can we authenticate to the system? Well, username and password, or an access key. An access key is a combination of a 20-character key ID and a 40-character secret jet. And the access key is what you use to connect to the AWS via an API call. So generally via the software development kit. So here you're dealing with a 60-character authentication session. Pretty good key. Let's talk about access keys and session tokens. Basically, what's going on here is when an IAM authentication needs to occur under an assumed role, a token is given, etc., etc., etc. So now we talked about authentication. I'd say let's do this. Let's stop here, take 5 minutes of questions, It'll be a 4-hour day tomorrow, but we're going to finish tomorrow, and that way nobody has to work the weekend. I mean, I will be doing stuff over the weekend, but hopefully you guys can be studying and building your careers over the weekend. Haley, can I explain in simpler terms what a principal is? It always confuse you. A user or an entity. That's it. Good question, Hillary. You're confused by WAF, network ACLs, and security groups. So here's the thing. We covered it extensively, so if you missed it, please go back and see it. But WAF is a firewall that you could use to secure your VPC, although in most cases you'd be using something industrial, like something you'll get from the marketplace. And network ACL is an access control list that's used to protect the subnet. And a security group is basically a firewall that protects your servers. So WAF, external firewall, if you would use that. Although I use network load balancers in front of more next generation firewalls because I need the security. Network ACLs protect the subnet, and security groups protect the server. Chris, you can go to the next one. Good question there, and I see it a lot. Where does OAuth fit into this in the environment? Virus, that would get us deep into sys administration roles, which is kind of beyond the scope of this course. How does Microsoft AD authentication work with users in AWS? Kind of just covered that. What happens is you've got your AWS account, your Active Directory, and either via OAuth or SAML 2.0, you create a connection between the two of them, and AWS pulls the information directly from your systems, and tokens are exchanged. That's now at the architect level, not at the engineering level. Erwin, if our hacker were able to get into token used to log into the server, at the time of the token expiry, he's totally kicked out of the server. Absolutely, that's the key. So shorter your tokens, the less scalability you have, but the shorter your tokens, what do you have? You have a lot more security. Do you know if there's a way to monitor or limit a user connection bandwidth for security reasons? Well, it's funny because AWS just issued a press release that you can now monitor traffic through Transit Gateway. And I went, hey, we're back to 2000 again because Cisco could do that with NetFlow. So Cisco, you can monitor some traffic with NetFlow, and then you can monitor other net traffic with VPC flow logs. Now, Casio, if you're dealing with a real security environment, you're going to have an intrusion detection and intrusion prevention system. And that actually may make life easy for you. So kind of keep that in the back of your mind. So we have that. Now, in your data center, yeah, we can do a lot of things. We can do priority queuing and we can do rate limiting, etc. But on the cloud, you've got very limited ability to limit a user's connection. So there are some network monitoring tools they can use, but it's nowhere close to what you get in your data center. Nowhere close. Sean J., you're proud to say that you're now an official student of the Cloud Architecture Development Plus Live. Sean J., next week, I can't wait to meet you in class. And even more importantly, I can't wait until next year when you tell me you're hired. So welcome aboard. Can't wait to work with you. What's the difference between federated identity, Active Directory, and single sign-on? Very simple. Active Directory, servers that are your domain authentication for your Windows domain. Federated identity, use the cloud to use your Windows domain servers to determine who gets in and who gets out. Single sign-on, one password, you log in once, and you get access to all the systems that you're allowed access to. I'm in Linux systems engineering. Should I choose AWS, Kubernetes, or Docker? Suresh, what you're doing now has no bearing on your future. What did you eat yesterday's dinner? Can you eat whatever you want for breakfast today? Suresh, I've gotten 4 people, well, 4 or 5 in the last month or two that had never worked in tech before, cloud architect jobs because they wanted it. I've also gotten people any other kind of job they wanted. So what you've done in your past has no bearing on your future. What you choose to do determines your future. What do you want to do? Do you want to be a systems designer like a cloud architect? Do you want to be a cloud engineer who builds things? And, or by the way, do you want to be someone that actually does microservices and coding, like Kubernetes and Docker? It's up to you. What do you want to do? That's what you should do. What's the difference between a NAT gateway and an internet gateway, Hillary? The NAT gateway enables you to go out to the internet and retrieve stuff and let it come back, but it doesn't allow external people to connect to you. An internet gateway allows you to go out to the internet and come back. An internet gateway is just an internet-facing router. Chris, I can probably do 3 to 5 more minutes and then we must go. Dylan Williams, which did you enjoy more, being an engineer and architect? Dylan, for me, I much preferred being an architect, and here's the reason why. As an engineer, I worked twice as many hours for a third of the pay. And as the engineer, I did all the work, and the architects and the business people got the credit. Now, having said that, I loved my time in engineering. And for me, I much would prefer meeting with a client, delivering a presentation, and writing a document than staring at a computer screen all day long. I would much prefer to take my clients out to dinner and have a conversation, take my clients to play golf on the company's dime, than actually sit behind a computer and configure things. But there are people, Dylan, that don't like to present and don't like to sell. And if they love being hands-on tech, the engineer program like a cloud engineer is wonderful. And that's why I have both. For people that like to code, configure, and want to be hands-on, they're going to hate being an architect. And I can see them all the time. I want to be an architect, Mike. And I say, you're never going to touch the technology again. Sure, I will. I heard, Mike, you will never touch the technology again. You're going to design person themselves. And they say, but I'm like, you will never touch the technology. And as soon as you do, you will create an error that's so bad that you're going to cost businesses millions of dollars and be fired. I said, you can't be an engineer and an architect at the same time. So if you love the tech, please do the tech. I have friends. My friend Moses is the world's greatest engineer. When I go to his house, it senses me. It turns on a light. He claps. It does one thing to the things. He does another button on his phone. He's an engineer. He loves that. You get to my house, the VCR blinks 12. The DVD player blinks 12, because I don't feel like changing it. But when somebody calls me and they're a CEO of a company and they say, Mike, we're struggling here. I need this, this, and this. I'm willing to go there, talk to the executive, look at the balance sheet, financial statements, and make recommendations. And I enjoy that. So it's what do you really like to do? Both are equally valued. We architects are zero without our engineers. We make pretty PowerPoint slides, sales presentation. It's the engineers that bring it to life. For me, I enjoyed being an architect a lot more, but you might like something else. Pick what makes you happy. You can make money in anything. And as Mark Twain said, if you make your vacation or your holiday, your vocation, you'll never work a day in your life. When I left internal medicine 25 years ago, I've never worked since because I've been an architect the whole time, except for the engineering time, and I loved it. Okay, so I think we need to end on this so my family won't murder me because my brother's in town. So tomorrow might be 4 hours, but let's get you all cloud hired. So everybody, let's close on this. So actually, I'm going to close on the following things. If you want to get hired, we currently have 30% off of all of our programs. Right now, off of everything, use coupon code POTENTIAL. If you want to ask questions on your career, I'll be back at 9 a.m. Eastern, 2 p.m. UK time tomorrow. And you can ask me any questions you want about building your career, and I will guide you so you can do it with a laser-like focus to get to your goals as fast as possible. If you've not yet subscribed, please do so. Please hit the bell. If you haven't given us a like, please do so. It helps our rankings in the algorithm so we can deliver more free content to help more people build the best lives. If you haven't yet, please share this message of others so other people can have access to this free training. We put a tremendous amount of time, effort, and money into producing training content to help the world, so please do so. And you know what? It's been wonderful, wonderful to see you all. If we can end this and give me a hashtag, AWS Certified Solution to Architect Associate 2022. Hopefully I can see a couple of hundred of them. And please check out my LinkedIn post if you're not following me on LinkedIn. It's an article about how you can get hired in any economy. Pretty relevant stuff in today's world. I had so much fun with you. Everybody, it's been such an honor, such a privilege to spend the afternoon with you. Have a wonderful, 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 wonderful day. And thank you.